20 space megastructures could exist in the universe, and one day, humans might be capable of constructing some of them. For example, colony starships. Colony starships represent one of the most ambitious and exciting concepts for the future of humanity in space. These enormous spacecraft would be designed to carry large populations on long-duration missions, with the goal of establishing human colonies on distant planets or even in other star systems. Unlike the shorter trips undertaken by current space missions, colony starships would need to sustain their inhabitants for years, decades, or even centuries as they travel through the vast expanses of space. The successful development and deployment of such starships could play a crucial role in humanity's long-term survival and expansion beyond Earth. A colony starship would work as a self-sustaining closed-loop environment, essentially functioning as a small artificial world. It would be equipped with advanced life support systems that recycle air, water, and waste to maintain a stable and habitable environment for its passengers. These systems would need to be highly efficient and reliable, given the isolated nature of the starship and the impossibility of resupplying from Earth during its journey. Food production would be handled on board through hydroponic or aeroponic farming systems, where crops are grown without soil, using nutrient-rich water or mist. This would ensure a steady supply of fresh food for the crew and passengers. One of the key challenges in designing a colony starship is providing artificial gravity to counteract the effects of long-term weightlessness on the human body. One solution is to build the starship in a rotating design, where centrifugal force would create gravity-like conditions on the inside of the rotating sections. This would allow the inhabitants to walk, live, and work in an environment similar to Earth's, preventing the muscle and bone loss that occurs in microgravity. This rotating section could be designed as a large ring or cylinder, with living quarters, workspaces, and recreational areas built into the inner surface. In addition to its physical infrastructure, a colony starship would need to address the social and psychological needs of its inhabitants. Living in a confined space for extended periods can be challenging, so the starship would be designed with diverse and adaptable habitats that simulate natural environments, such as parks, forests, or even simulated weather patterns. Entertainment, education, and social interaction would be facilitated through advanced virtual reality systems, allowing passengers to stay connected with each other and with life on Earth. Psychological support and community building would be critical to maintaining the mental well-being of the starship's population. The benefits of colony starships for humanity are profound. First and foremost, they offer a way to ensure the long-term survival of our species. Earth is vulnerable to various existential threats, including natural disasters, pandemics, and potentially even man-made dangers like nuclear war or climate change. By establishing colonies on other planets or in other star systems, humanity would reduce its dependence on a single planet, ensuring that our species could continue to thrive even if Earth were to face a catastrophic event. Colony starships also hold the promise of expanding human civilization across the cosmos. By venturing beyond our solar system, we could discover new worlds with untapped resources, unique environments, and possibly even extraterrestrial life. This would open up new opportunities for scientific discovery, cultural exchange, and economic growth. As humanity spreads to new frontiers, we would carry with us the knowledge, culture, and diversity that make our civilization unique, creating new societies and ways of life in distant parts of the galaxy. In the future, colony starships could also serve as the foundation for a spacefaring economy. These starships could establish trade routes between Earth and newly colonized planets, exchanging goods, technology, and information across vast distances. The development of these starships would drive advancements in propulsion technology, materials science, and space infrastructure, with benefits that could be applied to other areas of space exploration and industry. The ability to travel and trade between star systems could lead to a new era of economic growth and innovation, with humanity taking its place as a multi-planetary civilization. Make sure to stick around to the end because this video explores Dyson spheres, O'Neill cylinders, ring worlds, planetary shields, wormholes, and more. Number 2. Dyson swarms. a Dyson swarm is an ambitious concept that could revolutionize humanity's approach to energy generation by harnessing the immense power of the sun. Unlike the more well-known Dyson sphere, which envisions a solid shell surrounding a star, a Dyson swarm consists of a vast number of individual satellites or solar collectors that orbit the star in a coordinated pattern. These satellites would capture a significant portion of the star's energy output and convert it into usable power, potentially providing near-limitless energy for humanity's needs. The idea behind a Dyson swarm is to create a distributed network of solar collectors that can be gradually expanded over time. Each satellite in the swarm would be equipped with advanced solar panels that capture sunlight and convert it into electricity. This energy could then be transmitted back to Earth or other locations in the solar system using wireless energy transfer technologies such as microwave beams or lasers. The modular nature of a Dyson swarm allows for flexibility in its construction because additional satellites can be added incrementally, each contributing to the overall energy output. One of the primary benefits of a Dyson swarm is its potential to solve humanity's energy challenges. By capturing even a small fraction of the sun's energy, a Dyson swarm could generate more power than all of Earth's current energy sources combined. This abundant energy supply could support the growing global demand for electricity, enable the widespread adoption of renewable energy, and provide the power needed for advanced technologies like artificial intelligence, space travel, and large-scale computing. In addition to meeting Earth's energy needs, a Dyson swarm could also support future space exploration and colonization efforts. The energy harvested by the swarm could power spacecraft, habitats, and other infrastructure in space, making it easier to establish colonies on the Moon, Mars, and beyond. This energy could also be used to fuel advanced propulsion systems, enabling faster and more efficient travel between planets and potentially even to other star systems. The availability of abundant energy in space would be a key enabler for humanity's expansion into the cosmos. Another significant advantage of a Dyson swarm is its potential to mitigate the environmental impact of energy production on Earth. By relying on the sun's energy, humanity could reduce its dependence on fossil fuels and nuclear power, which have associated risks and environmental consequences. A Dyson swarm could help reduce greenhouse gas emissions, slow climate change, and decrease pollution, contributing to a more sustainable and environmentally friendly energy future. Building a Dyson swarm would also drive technological innovation and create new industries. The construction of such a massive and complex structure would require advancements in materials science, robotics, and space manufacturing. Automated systems and self-replicating machines could be developed to construct and maintain the swarm, reducing the need for human intervention and making the process more efficient. The technologies developed for a Dyson swarm could have applications beyond space, benefiting industries on Earth in areas such as energy, telecommunications, and manufacturing. Moreover, the concept of a Dyson swarm aligns with the long-term vision of humanity becoming a Type II civilization on the Kardashev scale, a society that can harness the energy output of an entire star. Achieving this level of technological and energy capability would represent a significant milestone in human progress, enabling us to address global challenges more effectively and pursue more ambitious goals, such as interstellar exploration and the search for extraterrestrial life. Number 3. O'Neill cylinders. O'Neill cylinders are a fascinating concept for space habitats that could one day provide a home for millions of people beyond Earth. Proposed by physicist Gerard K. O'Neill in the 1970s, these gigantic cylindrical structures would rotate in space to create artificial gravity on their inner surfaces, allowing people to live and work in a comfortable, Earth-like environment. O'Neill cylinders are envisioned as a solution to overpopulation, resource scarcity, and the challenges of sustaining large human populations in space, making them a key element in humanity's future as a spacefaring civilization. Jeff Bezos has also proposed this megastructure as a viable solution for the future. An O'Neill cylinder would work by using centrifugal force to simulate gravity. The cylinder, which could be as long as 20 miles and several miles in diameter, would rotate around its central axis. This rotation would push everything inside outward toward the inner surface of the cylinder, creating a gravity-like effect that would allow people to walk, live, and build as they would on Earth. The inner surface of the cylinder would be divided into different zones, with some areas dedicated to cities, others to agriculture, and still others to natural landscapes. Large windows made from transparent materials would allow sunlight to enter, providing natural light and enabling photosynthesis for plants. In addition to providing living space, O'Neill cylinders could be a hub for advanced industry and research. The microgravity environment outside the cylinder, combined with the controlled environment inside, would make it an ideal location for manufacturing high-tech materials, pharmaceuticals, and other products that are difficult to produce on Earth. Research facilities in O'Neill cylinders could also conduct experiments in fields like physics, biology, and material science that take advantage of the unique conditions in space. This could lead to new discoveries and innovations that benefit both the inhabitants of the cylinder and people on Earth. O'Neill cylinders could also play a crucial role in the colonization of the solar system. Positioned in orbit around Earth, the Moon, or other planets, these cylinders could serve as way stations for missions to Mars, the asteroid belt, and beyond. They could provide a base of operations for mining asteroids, extracting valuable resources such as metals and water, and processing them into useful materials. The resources gathered from space could then be used to build more O'Neill cylinders, further expanding humanity's presence in the solar system and creating a self-sustaining cycle of growth and development. Another key benefit of O'Neill cylinders is their potential to create a more sustainable and equitable society. The controlled environment of the cylinder would allow for the implementation of advanced agricultural techniques such as vertical farming and hydroponics, which could produce food more efficiently and with less environmental impact than traditional farming methods. The abundance of solar energy in space could be harnessed to power the cylinder, providing a clean and virtually limitless source of energy. These factors, combined with the vast living space available, could enable the creation of a society that is less dependent on finite resources and more focused on sustainability and long-term well-being. In the future, O'Neill cylinders could also become cultural and educational centers, preserving and promoting human knowledge, art, and traditions. As humanity spreads across the solar system, these cylinders could serve as repositories of culture and history, ensuring that our shared heritage is not lost as we explore new worlds. Educational institutions within the cylinders could provide training in the skills needed for life in space, preparing future generations for the challenges and opportunities of a spacefaring civilization. Number 4. Planetary shields. A planetary shield is a visionary concept that could play a crucial role in protecting Earth or other planets from a range of potential threats, both natural and artificial. This immense structure, or series of interconnected structures, would be designed to shield a planet from hazards such as asteroid impacts, solar radiation, space debris, and even hostile attacks. By acting as a protective barrier, a planetary shield could safeguard the inhabitants of a planet, ensuring the continuity of life and the stability of the environment. The concept of a planetary shield could be realized through several different technologies, depending on the specific threats it is designed to counter. For instance, to protect against asteroids and space debris, the shield could consist of a network of high-powered laser systems or electromagnetic railguns positioned in orbit around the planet. These systems would be capable of detecting incoming objects and either deflecting or destroying them before they could reach the surface. The lasers could vaporize smaller debris or alter the trajectory of larger asteroids, preventing catastrophic impacts that could cause widespread destruction. To shield against solar radiation, particularly harmful solar flares or coronal mass ejections, the planetary shield might incorporate large arrays of magnetic field generators placed in strategic locations around the planet. These generators would create a powerful artificial magnetic field, similar to Earth's natural magnetosphere, which could deflect charged particles from the sun. This would protect the planet's atmosphere from being stripped away and shield electronic systems from the damaging effects of intense solar radiation, thereby preventing disruptions to communication networks, power grids, and satellites. In the context of planetary defense against potential hostile attacks, the planetary shield could be equipped with advanced missile defense systems, particle beams, or even a form of energy barrier. These defense systems would be capable of intercepting and neutralizing any threats before they could cause harm. The presence of such a shield could serve as a deterrent, discouraging potential aggressors from attempting to attack the planet. Additionally, the shield could provide a layer of protection for planetary infrastructure, ensuring the safety of critical assets such as space stations, satellites, and spaceports. The benefits of a planetary shield for humanity are profound. One of the most immediate advantages would be the protection of human life and infrastructure from natural disasters like asteroid impacts. Historically, large asteroid collisions have caused mass extinctions and significant environmental changes on Earth. A planetary shield could prevent such events from occurring, preserving the planet's ecosystems and preventing loss of life on a massive scale. This would be particularly important as humanity continues to expand its presence in space, with more satellites, space stations, and potentially colonies in orbit or on other celestial bodies. Beyond protection from natural threats, a planetary shield could also play a crucial role in maintaining global stability in the face of human-made dangers. As space becomes increasingly militarized and the potential for conflicts in space grows, having a planetary defense system in place could prevent catastrophic attacks on Earth or other inhabited planets. This would reduce the risk of large-scale warfare in space, helping to maintain peace and security on a global scale. Moreover, the development and deployment of a planetary shield would drive significant advancements in technology and science. The research and engineering required to create such a shield would lead to breakthroughs in fields such as materials science, energy generation, and space-based sensors. These advancements could have wide-ranging applications, improving technologies on Earth and enabling new capabilities in space exploration. For example, the technology developed for a planetary shield could be adapted for use in protecting space habitats, lunar bases, or Martian colonies, ensuring the safety of humans living and working beyond Earth. In the future, a planetary shield could also support the terraforming efforts on other planets. By controlling and regulating the amount of solar radiation that reaches a planet's surface, the shield could help create more stable and habitable environments. This would be particularly useful in the early stages of colonization, where managing the planet's climate and protecting new settlements from space weather would be critical to the success of the mission. Number 5. Ringworlds. Ringworlds are a fascinating and ambitious concept in the realm of space megastructures, offering the potential to create vast, habitable environments far beyond what is possible on Earth. A ringworld is essentially a massive ring that orbits a star, with its inner surface designed to support life. This ring would be constructed at a distance from the star where temperatures would be suitable for human habitation, creating an artificial world with an area millions of times greater than the surface of Earth. The idea, popularized by science fiction author Larry Niven, could represent the ultimate solution to the challenges of overpopulation, resource scarcity, and the quest for sustainable living spaces. A ringworld would work by using centrifugal force to simulate gravity. The entire structure would rotate around its star, with the outer edge of the ring spinning at such a speed that it creates a gravitational pull on the inhabitants and objects on its inner surface. This would allow people to live, walk, and build on the ring's surface as they would on Earth, despite the structure being located in space. The ring's immense surface area would provide ample space for cities, agriculture, and natural environments, potentially accommodating billions or even trillions of people. One of the most significant benefits of a ringworld is its potential to solve the issue of overpopulation. With a habitable area far greater than that of Earth, a ringworld could support a vast population, providing them with space to live, work, and thrive. This would alleviate the pressures on Earth's ecosystems and resources, allowing for more sustainable development and conservation of the natural environment. The abundance of space on a ringworld would also enable the creation of expansive green areas, parks, and natural reserves, enhancing the quality of life for its inhabitants. In addition to providing living space, a ring world could offer unparalleled access to resources. The structure could be designed with advanced technology to harvest solar energy directly from its star, providing virtually limitless power to its inhabitants. This energy could be used to support industries, agriculture, and the overall infrastructure of the ring world, making it largely self-sufficient. Furthermore, the ring world could be equipped with systems to capture and recycle resources, minimizing waste and ensuring the sustainability of the environment. Another intriguing aspect of a ring world is its potential for scientific research and exploration. The unique environment of a ring world, combined with its proximity to a star, would provide opportunities to study astrophysics, planetary science, and other fields in ways that are not possible on Earth. The vast size of the ring world would also enable the establishment of research centers, observatories, and laboratories dedicated to advancing human knowledge. However, the sheer amount of material needed to construct a ring world is staggering. Even if we dismantled every planet, moon, and asteroid in our solar system, it still might not provide enough matter to build such a structure. This is why a ring world is often seen as a far future megastructure, potentially feasible only in another solar system. In the far future, a ring world could serve as a model for future space colonies, enabling humanity to establish a presence across the galaxy and ensuring the continued growth and expansion of our civilization. Number 6. Wormholes. Wormholes are a theoretical concept in physics that could revolutionize space travel by providing shortcuts through space-time, connecting distant regions of the universe in an instant. Often depicted in science fiction, wormholes, if they exist, would function like tunnels with two ends at separate points in space and time. This means that traveling through a wormhole could allow someone to traverse vast distances that would otherwise take thousands or even millions of years to cover using conventional space travel methods. The idea of wormholes originates from Einstein's theory of general relativity, which describes how massive objects warp the fabric of space-time. According to this theory, it is theoretically possible for space-time to be folded or bent in such a way that two distant points touch, creating a shortcut between them, a wormhole. In practice, a wormhole would consist of two mouths connected by a throat, and passing through the throat would instantly transport you from one mouth to the other, regardless of the distance between them, in normal space. For wormholes to work as practical transportation devices, they would need to be stable and large enough for spacecraft to pass through. However, one of the significant challenges with wormholes is that they are predicted to be highly unstable. The immense gravitational forces involved could cause them to collapse or close before anything could pass through. Some theories suggest that exotic matter with negative energy density could be used to stabilize a wormhole, preventing it from collapsing and allowing safe passage. The potential benefits of wormholes for humanity are extraordinary. The most obvious advantage is the possibility of interstellar travel in a fraction of the time it would take using conventional methods. Instead of spending decades or centuries traveling to the nearest stars, wormholes could allow for near instantaneous travel between distant parts of the galaxy. This would open up the universe for exploration and colonization, enabling humanity to establish settlements on far-off planets, access new resources, and potentially encounter other forms of intelligent life. Wormholes could also revolutionize communication across vast distances. Currently, communicating with spacecraft or colonies on other planets involves significant time delays due to the finite speed of light. Wormholes could eliminate these delays by providing a direct link between two distant points, allowing for real-time communication across the galaxy. This would be crucial for coordinating space missions, sharing scientific data, and maintaining connections between human settlements spread across different star systems. Beyond their practical applications for travel and communication, wormholes could also provide valuable insights into the nature of the universe. Studying and understanding how wormholes work could lead to breakthroughs in fundamental physics, shedding light on the mysteries of space-time, gravity, and quantum mechanics. The existence of wormholes could also offer evidence for the theory of multiverses, suggesting that there are other universes beyond our own that could be accessed through these cosmic tunnels. The potential for wormholes to connect not just distant points in space, but also different times, adds another layer of intrigue. Theoretical models suggest that a wormhole could link different points in time, potentially enabling time travel. While this idea raises complex questions about causality and the nature of time itself, it also opens up fascinating possibilities for exploration and discovery, allowing humanity to learn more about the history of the universe or even influence future events. In the future, if wormholes were proven to exist and could be safely traversed, they could fundamentally alter the trajectory of human civilization. The ability to travel across the galaxy and beyond would expand humanity's reach, allowing us to explore and settle in regions of space that are currently beyond our grasp. This could lead to the development of a galactic civilization, where humanity spreads out among the stars, thriving in multiple star systems and ensuring the long-term survival of our species. Number 7. Matryoshka brains. Matryoshka brains are an advanced and speculative concept in the realm of space megastructures, representing a vision of ultimate computational power. Named after the Russian nesting dolls which stack within one another, a Matryoshka brain would consist of a series of concentric Dyson spheres, each one encompassing the previous layer, built around a star. These layers would be made of advanced solar collectors and computational nodes, allowing the entire structure to harness the star's energy and convert it into an almost incomprehensible amount of computing power. The core idea of a Matryoshka brain is to maximize the use of a star's energy output by capturing it at multiple levels. The innermost shell would be a traditional Dyson sphere, which directly absorbs energy from the star. Surrounding this inner sphere, additional layers would be constructed, each absorbing the energy radiated by the layer beneath it. This process would continue outward, with each successive shell capturing and utilizing energy that would otherwise be lost to space. The outermost layer would radiate minimal heat, making the Matryoshka brain an incredibly efficient system for energy utilization. The computing power of a Matryoshka brain would be virtually limitless. Each layer would be packed with computational nodes that operate at incredibly high speeds, processing information and running simulations on a scale far beyond anything currently imaginable. This immense computational capacity could be used for a wide range of applications, from running detailed simulations of the universe to solving complex problems in science, mathematics, and technology. It could even support the creation of highly sophisticated artificial intelligence systems, enabling the development of entities with intelligence surpassing all humans who have ever lived. One of the most profound benefits of a Matryoshka brain would be its potential to advance scientific knowledge and understanding. With its vast computational resources, a Matryoshka brain could simulate entire ecosystems, weather patterns, or even the universe itself. It could help humanity explore the deepest mysteries of physics, such as the nature of dark matter, the behavior of quantum particles, or the origins of the universe. By running simulations of different scenarios, it could predict the outcomes of various cosmic events, from the formation of galaxies to the evolution of stars. Additionally, a Matryoshka brain could revolutionize the field of artificial intelligence. With its immense processing power, it could support the creation of AI entities with unparalleled cognitive abilities. These AI systems could assist in solving some of humanity's greatest challenges, from climate change to disease eradication, by processing and analyzing vast amounts of data more efficiently than any human could. The Matryoshka brain could also simulate entire societies or virtual worlds, allowing for the exploration of different social, economic, and technological systems in a controlled environment. Furthermore, the potential for digital immortality could be realized within a Matryoshka brain. Humans could upload their consciousness into the structure, effectively achieving a form of digital immortality, where their minds continue to exist and evolve within the virtual environment created by the Matryoshka brain. This could allow individuals to live out multiple lifetimes, exploring different experiences, worlds, and realities in a safe and controlled environment. This concept of mind uploading could fundamentally change the nature of human existence, offering new possibilities for personal growth, learning, and exploration. Number 8. Space elevators. Space elevators are one of the most intriguing and potentially transformative concepts in the field of space exploration. A space elevator would be a giant structure extending from Earth's surface to a point far beyond geostationary orbit, around 22,000 miles above the equator. This structure would enable the transportation of materials, equipment, and even people into space without the need for rockets, drastically reducing the cost and environmental impact of accessing space. The idea, first proposed in the late 19th century, has gained renewed interest as materials science and engineering have advanced, making it a more plausible endeavor in the future. The core of a space elevator would be its tether, an immensely strong and lightweight material that could stretch from Earth's surface to space. The most promising candidate for this tether is carbon nanotubes or graphene, materials that are incredibly strong yet lightweight enough to make the concept feasible. The tether would be anchored to a platform at the equator and extend upward to a counterweight in space, beyond geostationary orbit. This counterweight would keep the tether taut through the centrifugal force generated by Earth's rotation, effectively balancing the entire structure. To travel up and down the space elevator, specially designed vehicles called climbers would be used. These climbers would be electrically powered, possibly through solar energy or beamed power from the ground, and would ascend or descend along the tether. Unlike rockets, which require vast amounts of fuel and generate significant pollution, these climbers would operate more like elevators in a skyscraper, providing a smooth, continuous journey into space. The benefits of space elevators for humanity could be profound. One of the most significant advantages is the potential to dramatically reduce the cost of sending materials and people into space. Currently, launching payloads into orbit using rockets is extremely expensive, often costing thousands of dollars per kilogram. A space elevator could reduce these costs by a factor of 100 or more, making space more accessible for a wide range of activities, from scientific research to commercial ventures. This reduction in cost could spur a new era of space exploration and development, enabling the construction of space habitats, factories, and even space-based solar power stations that could provide clean energy for Earth. In addition to lowering costs, space elevators could also reduce the environmental impact of space travel. Traditional rocket launches generate significant pollution, both in the atmosphere and on the ground, where rocket fuel and other chemicals can cause environmental damage. By using electric-powered climbers, space elevators would produce little to no emissions, making them a far more sustainable option for accessing space. This would be particularly important as the demand for space travel increases, helping to ensure that humanity's expansion into space does not come at the expense of Earth's environment. Another important benefit of space elevators is their potential to enable large-scale construction projects in space. With the ability to transport massive amounts of materials to orbit at a low cost, space elevators could facilitate the building of space habitats, research stations, and even spacecraft. These structures could be assembled in space where there are no gravitational constraints, allowing for the creation of megastructures that would be impossible to build on Earth. This capability could accelerate the colonization of the Moon, Mars, and other celestial bodies, as well as the development of space-based industries that could drive economic growth and innovation. Number 9. Orbital mining stations. Orbital mining stations represent a transformative concept in space exploration and resource acquisition, offering humanity the potential to access the vast wealth of materials available in asteroids, moons, and other celestial bodies. These stations would serve as hubs for mining operations in space, extracting valuable minerals, metals, and other resources directly from these celestial bodies and processing them in orbit. The idea of orbital mining is rooted in the understanding that many of the materials that are rare or difficult to obtain on Earth exist in abundance in space, particularly in asteroids, which are rich in elements like platinum, gold, nickel, and water. An orbital mining station would work by positioning itself near an asteroid or another resource-rich body, such as a moon or a small planet. The station would be equipped with advanced robotics, autonomous mining equipment, and processing facilities designed to operate in the harsh conditions of space. These machines would mine the target body, extracting raw materials and transporting them to the station for processing. Once processed, these materials could be used directly in space, for example, in the construction of space habitats, satellites, or other megastructures, or transported back to Earth for use in various industries. One of the most significant benefits of orbital mining stations is their potential to revolutionize resource availability on Earth. As our planet's population grows and the demand for raw materials increases, the pressure on Earth's finite resources becomes more intense. By tapping into the virtually limitless supply of materials in space, orbital mining stations could alleviate this pressure, providing a new source of critical resources like rare metals and water. This could reduce the environmental impact of mining on Earth, preserving ecosystems and reducing the degradation of natural landscapes. In addition to supplying materials for Earth, orbital mining stations could play a crucial role in the development of space infrastructure. The construction of space habitats, solar power stations, and other megastructures requires vast amounts of material, much of which would be prohibitively expensive to launch from Earth due to the high cost of space transportation. By sourcing these materials directly from space, orbital mining stations could significantly reduce the cost and complexity of building in space, making large-scale projects more feasible. This could accelerate the development of space colonies, research stations, and other facilities that support a growing human presence in space. Moreover, orbital mining stations could contribute to the sustainability and longevity of space missions. Water, for example, is a critical resource for life support systems, as well as for producing rocket fuel through electrolysis. By extracting water from asteroids or moons and processing it in orbit, these stations could provide a reliable and cost-effective supply of fuel and life support resources for missions to the Moon, Mars, and beyond. This would enable longer and more ambitious missions, reducing the need for resupply missions from Earth and increasing the autonomy of spacecraft and space habitats. The economic potential of orbital mining stations is also immense. The value of the materials available in just a single asteroid can be staggering. Some estimates suggest that the resources in certain asteroids could be worth trillions of dollars. By establishing a network of orbital mining stations, humanity could tap into this wealth, driving economic growth and creating new industries centered around space resource extraction and processing. This could lead to the development of new markets, job creation, and technological innovation, further integrating space into the global economy. In the future, orbital mining stations could also support interplanetary trade and the creation of a space-based economy. As humanity expands its presence in space, the need for materials and goods in orbit will increase. Orbital mining stations could serve as nodes in a supply chain that stretches across the solar system, providing the raw materials needed for construction, manufacturing, and life support in space. This could enable the growth of space colonies and the establishment of trade routes between Earth, the Moon, Mars, and other locations, fostering a vibrant and interconnected space economy. Number 10. Penrose spheres around black holes. Penrose spheres are an ambitious and speculative concept in the realm of space megastructures, inspired by the theoretical ideas of physicist Roger Penrose. These structures are designed to harness the immense energy found in the vicinity of a rotating black hole. Unlike traditional energy sources, which rely on chemical, nuclear, or solar power, Penrose spheres would tap into one of the most powerful and mysterious forces in the universe, the rotational energy of a black hole. The basic idea behind a Penrose sphere is to create a massive spherical structure that encircles a rotating black hole, known as a Kerr black hole. The black hole's rotation causes the surrounding space-time to twist in a phenomenon known as frame dragging. This effect creates an ergosphere, a region just outside the event horizon where objects can potentially gain energy by following specific trajectories. A Penrose sphere would be designed to capture this energy by carefully manipulating objects or particles within the ergosphere, extracting energy from the black hole's rotation without falling into it. In practical terms, the Penrose process involves sending material into the ergosphere on a precise trajectory. Once inside this region, the material would split into two parts. One part falls into the black hole, while the other escapes with more energy than it originally had. The escaping material, now energized, could be collected and converted into usable power. By repeating this process continuously, a Penrose sphere could theoretically extract vast amounts of energy from the black hole, effectively using it as a cosmic power plant. The benefits of a Penrose sphere for humanity could be profound. First and foremost, it offers a nearly limitless source of energy. The rotational energy of a black hole is immense, and a Penrose sphere could harness this energy for countless applications. This could provide power not only for space-based infrastructure, such as space stations, habitats, and spacecraft, but also for advanced technologies that require enormous amounts of energy, such as large-scale simulations, artificial intelligence, and even interstellar propulsion systems. In addition to energy generation, Penrose spheres could play a critical role in deep space exploration and colonization. The ability to harness the energy of a black hole would enable long-term sustainable human presence in regions of space far from the sun or other stars. This would allow humanity to establish colonies and research stations near black holes, exploring some of the most extreme and intriguing environments in the universe. The proximity to a black hole would also provide unique opportunities for scientific research, potentially leading to breakthroughs in our understanding of gravity, quantum mechanics, and the nature of space-time. Another intriguing possibility is the use of Penrose spheres in the development of advanced propulsion systems. The energy extracted from a black hole could be used to power spacecraft capable of reaching incredible speeds, potentially even allowing for faster-than-light travel through theoretical concepts such as warp drives or wormholes. This could revolutionize space travel, making interstellar journeys feasible and opening up the entire galaxy for exploration and colonization. The construction of a Penrose sphere would be an unprecedented engineering challenge, requiring materials and technologies that are currently beyond our reach. However, the pursuit of this concept could drive significant advancements in fields such as materials science, energy storage, and space construction. Number 11. Interplanetary relay networks. An interplanetary relay network is a visionary concept designed to enhance communication across the vast distances of our solar system, serving as the backbone for interplanetary exploration, colonization, and commerce. As humanity sets its sights on establishing a presence on other planets and moons, the need for reliable, high-speed communication between Earth and these distant outposts becomes increasingly critical. An interplanetary relay network would address this need by creating a network of satellites, space stations, and ground-based relays that facilitate seamless communication across millions or even billions of kilometers. The concept of an interplanetary relay network revolves around deploying a series of communication satellites in strategic orbits around planets, moons, and other key locations in the solar system. These satellites would be equipped with advanced communication technologies, such as high-frequency radio waves, lasers, or even quantum communication systems, to transmit data at the highest possible speeds. The network would be designed to ensure that signals can be transmitted continuously, avoiding the delays and interruptions that currently occur when spacecraft or planets move out of alignment with Earth. Each relay station in the network would act as a node, receiving, amplifying, and forwarding signals from one location to another. For example, a signal sent from a Mars colony could be transmitted to a satellite orbiting Mars, which would then relay the signal to another satellite positioned between Mars and Earth, and finally to a receiving station on Earth. This relay system would allow data to travel across the solar system with minimal delay, enabling real-time communication and data exchange between Earth and distant space missions. The benefits of an interplanetary relay network for humanity are numerous and far-reaching. First and foremost, it would vastly improve the safety and effectiveness of space exploration missions. Currently, communication delays between Earth and Mars can range from several minutes to over 20 minutes, depending on the planet's relative positions. These delays can hinder mission control's ability to respond to emergencies or guide rovers and spacecraft in real time. An interplanetary relay network would reduce these delays, enabling faster decision-making and more precise control over missions, thereby enhancing the safety and success of space exploration. In addition to improving mission control, an interplanetary relay network would be essential for supporting human settlements on other planets and moons. As colonies on Mars, the Moon, and other celestial bodies become a reality, the need for reliable communication will be paramount. Colonists will need to communicate with Earth for everything from coordinating supply shipments to staying in touch with loved ones. The network would ensure that these communications are as seamless as possible, helping to maintain a strong connection between Earth and its off-world colonies. The network would also be crucial for scientific research and data collection. As space probes, telescopes, and landers explore distant planets, moons, and asteroids, they generate vast amounts of data that must be transmitted back to Earth for analysis. An interplanetary relay network would provide the bandwidth and reliability needed to transmit high volumes of data quickly and accurately. This would accelerate scientific discoveries, enabling researchers to analyze new information in near real time and make groundbreaking advancements in our understanding of the solar system. Moreover, an interplanetary relay network could pave the way for the development of an interplanetary internet, connecting not just Earth, but also multiple planets, moons, and space stations in a vast digital network. This would allow for the creation of new forms of communication, commerce, and collaboration across the solar system. For example, companies could establish interplanetary business operations, researchers could collaborate on projects in real time from different planets, and individuals could access entertainment, education, and social networks from anywhere in the solar system. In the future, the interplanetary relay network could also play a critical role in supporting interstellar exploration. As humanity looks beyond our solar system to explore nearby star systems, the relay network could be expanded to include deep space communication stations, enabling long-distance communication with interstellar probes, and potentially even with other civilizations. Number 12. Stellar engines. Stellar engines are a theoretical concept for gigantic space megastructures designed to move entire stars and their surrounding solar systems. The idea is both awe-inspiring and incredibly ambitious, as it envisions humanity gaining control over the movement of stars, effectively steering entire solar systems through the galaxy. While this might sound like science fiction, the concept is rooted in the laws of physics and represents a fascinating exploration of what could be possible in the distant future. A stellar engine would work by harnessing the energy output of a star to generate thrust, gradually pushing the star and everything in its orbit in a specific direction. One of the most well-known designs for a stellar engine is the Shkadov thruster, named after the Russian physicist Leonid Shkadov who proposed it. This design involves constructing a massive reflective structure, such as a giant mirror or a Dyson sphere-like surface, that partially surrounds the star. The structure would reflect a portion of the star's light back toward it, creating a pressure imbalance that would exert a gentle but continuous thrust on the star. Over time, this thrust would accumulate, causing the star to move slowly through space. Another more advanced design is the Kaplan thruster, which combines the principles of a Dyson sphere and a fusion-based propulsion system. In this concept, a large structure would capture solar energy and use it to power a fusion engine that expels high-velocity plasma or other propellant. This expelled material would push against the star, creating a reaction force that moves the entire system. The Kaplan thruster could potentially generate more significant thrust than the Shkadov thruster, making it a more powerful and efficient method for moving stars. Stellar engines could enable humanity to explore and colonize new regions of the galaxy. By moving our solar system closer to other stars, we could make interstellar travel more feasible, reducing the distances between solar systems and opening up new opportunities for exploration and settlement. This could lead to the establishment of human colonies on exoplanets or in other star systems, spreading life across the galaxy and creating a network of interconnected civilizations. Stellar engines could also play a role in the long-term management of the galaxy's resources. As humanity expands and consumes more energy, access to new sources of energy will become increasingly important. By moving our solar system to regions of the galaxy rich in resources, such as areas with high concentrations of dark matter or other valuable materials, we could ensure a steady supply of energy and resources for future generations. This would enable the continued growth and development of human civilization on a galactic scale. Number 13. Space-based particle accelerators. Space-based particle accelerators represent an extraordinary leap in scientific ambition, taking the concept of particle physics research to new cosmic heights. These colossal machines would be designed to accelerate subatomic particles to nearly the speed of light, enabling experiments that could probe the deepest mysteries of the universe. By constructing these accelerators in the vacuum of space, far beyond the limitations of Earth-bound facilities, scientists could achieve energies and conditions unattainable on our planet, leading to groundbreaking discoveries that could reshape our understanding of physics and the cosmos. A space-based particle accelerator would operate on the same basic principles as those on Earth, such as the Large Hadron Collider at CERN, but on an incomparably larger scale. Particles, such as protons or electrons, would be injected into the accelerator and guided along a circular or linear path by powerful magnetic fields. As the particles travel through the accelerator, they would be subjected to electromagnetic fields that accelerate them to incredible speeds, approaching the speed of light. These high-energy particles would then be collided with each other or with stationary targets, allowing scientists to observe the resulting interactions and study the fundamental forces in particles that make up the universe. Building a space-based particle accelerator offers several distinct advantages over Earth-based facilities. The most significant is the absence of atmospheric and gravitational constraints. In the vacuum of space, particles can be accelerated over much longer distances without losing energy to air resistance or being affected by Earth's gravity. This allows for the construction of much larger accelerators, potentially spanning hundreds or even thousands of kilometers. The larger the accelerator, the higher the energy levels that can be achieved, enabling the study of phenomena that require extreme conditions, such as those present in the early moments of the universe. Another advantage of constructing particle accelerators in space is the reduced risk of radiation exposure to humans and the environment. High-energy particle collisions can produce intense radiation, including harmful gamma rays and other forms of ionizing radiation. By placing these accelerators in space, far from Earth, the potential dangers associated with these experiments would be minimized, allowing scientists to conduct more powerful and ambitious experiments without risking public safety. One of the most profound benefits of a space-based particle accelerator would be its potential to answer fundamental questions about the nature of the universe. For instance, these accelerators could recreate conditions similar to those just after the Big Bang, allowing scientists to study the formation of matter, the behavior of dark matter, and the unification of fundamental forces. By achieving higher energies than those possible on Earth, these accelerators could explore new realms of physics, potentially leading to the discovery of unknown particles or forces, and deepening our understanding of the fabric of reality. In addition to advancing our knowledge of fundamental physics, space-based particle accelerators could have practical applications that benefit humanity. For example, they could be used to test and develop new materials and technologies that can withstand extreme conditions, such as those encountered in space exploration or nuclear fusion reactors. These advancements could lead to more durable spacecraft, improved energy production methods, and new industrial processes that enhance sustainability and efficiency. In the future, a network of space-based particle accelerators could be established across the solar system, providing a platform for continuous and collaborative research on an unprecedented scale. Such a network could bring together scientists from around the world, fostering international cooperation and shared knowledge. The data generated by these accelerators could revolutionize our understanding of the universe, leading to new theories and discoveries that could reshape the course of human history. Number 14. Universal constructors. Universal constructors in space represent one of the most ambitious concepts in the field of space exploration and megastructure construction. These theoretical machines, sometimes referred to as von Neumann machines, after the mathematician who first conceived the idea, are designed to be fully autonomous, self-replicating robots capable of building virtually anything, including themselves. Operating in space, these universal constructors could revolutionize humanity's ability to construct large-scale structures and harness resources from other planets, asteroids, and beyond. A universal constructor would work by first using raw materials available in space, such as the minerals found in asteroids, moons, or even planetary surfaces, to create components and machinery. These materials would be mined, refined, and processed by the constructor itself, which would then use them to fabricate new units or to assemble complex structures. One of the most critical aspects of these machines is their ability to replicate themselves, meaning that a single universal constructor could build copies of itself, exponentially increasing the number of constructors working in space. This self-replication process could turn a small initial investment into a vast fleet of machines capable of undertaking massive construction projects across the solar system. The potential benefits of universal constructors for humanity are immense. One of the most significant advantages would be their ability to construct large-scale space infrastructure without the need for constant resupply from Earth. This could include building space habitats, solar power stations, or even planetary defense systems. By using local resources and being fully autonomous, universal constructors would reduce the need for costly and risky launches from Earth, making space exploration and development more sustainable and affordable. Another profound benefit of universal constructors would be their role in asteroid mining. The vast resources locked within asteroids, such as rare metals and water, could be harnessed by these machines to support both Earth's economy and future space colonization efforts. The extracted materials could be used to build space habitats, fuel stations, or other essential infrastructure, potentially leading to a self-sufficient space economy. Moreover, by mining asteroids and other celestial bodies, humanity could reduce the environmental impact of mining on Earth, preserving our planet's ecosystems while still meeting the growing demand for resources. Universal constructors could also play a crucial role in the construction of space megastructures, such as Dyson spheres or O'Neill cylinders. These colossal structures, designed to harness massive amounts of energy or provide living space for millions of people, would require the assembly of materials on an unprecedented scale. Universal constructors, with their ability to replicate and work autonomously, would be the perfect solution to the logistical challenges of building such megastructures. They could operate in the vacuum of space, assembling components piece by piece over long periods, eventually creating structures that would be impossible to build using traditional methods. In the future, as technology advances, universal constructors could even be used to terraform planets or moons, making them suitable for human habitation. By constructing vast networks of infrastructure and altering the environment of these celestial bodies, these machines could lay the groundwork for new human colonies, extending humanity's reach into the cosmos. This capability would be essential for long-term survival and expansion, allowing humans to establish a presence on multiple planets and reduce the risk of extinction from global catastrophes on Earth. Moreover, the development and deployment of universal constructors could lead to a new era of exploration and discovery. With a fleet of self-replicating machines, humanity could explore the farthest reaches of the solar system and beyond, building research stations, telescopes, and communication networks to study the universe in greater detail. Number 15. Dyson spheres. Dyson spheres are one of the most ambitious and iconic concepts in the realm of space megastructures, representing a theoretical structure designed to harness the total energy output of a star. Named after the physicist Freeman Dyson, who popularized the idea in the 1960s, a Dyson sphere would be an enormous shell surrounding a star, capturing and converting its radiant energy into usable power. The idea stems from the notion that as a civilization grows and its energy needs increase, it would eventually seek to capture the full energy potential of its star, propelling it to a new level of technological advancement. Since Dyson spheres are quite similar to Dyson swarms, which were discussed earlier, I won't go into detail about their energy benefits. One of the most compelling aspects of a Dyson sphere is its potential to serve as a habitat for an enormous population. The sheer scale of the structure means that it could provide living space for trillions of people, far exceeding the capacity of Earth. Each habitat within the Dyson swarm could be designed with artificial gravity, climate control, and ecosystems tailored to human needs, offering a comfortable and Earth-like environment in space. These habitats could be connected through a network of transportation systems, communication links, and energy grids, creating a cohesive and interconnected civilization spread across millions of individual units. Given the potential material limitations within our solar system, constructing a Dyson sphere might be more feasible in another solar system in the distant future. Additionally, if alien civilizations have constructed Dyson spheres, these structures could serve as markers to identify and locate those civilizations. Number 16. Starlifters. Starlifters are an advanced and speculative concept in the field of space megastructures, representing one of the most ambitious ideas for harnessing the vast energy and material resources of stars. The idea behind a starlifter is to construct a massive structure or system capable of extracting matter directly from a star, such as our Sun, to utilize its elements for various purposes. This process could enable humanity to access enormous quantities of raw materials, potentially transforming our ability to build large-scale space structures and sustain long-term space exploration. A starlifter would work by creating a mechanism that could reach into the outer layers of a star and extract its material without disrupting the star's stability. This could be achieved using advanced technologies like powerful magnetic fields, solar sails, or even a series of interconnected tethers designed to pull stellar material away from the star's surface. Once extracted, the matter could be processed and separated into its constituent elements, such as hydrogen, helium, and heavier metals, which could then be used for various applications. One of the primary uses of the material harvested by a starlifter would be in the construction of other space megastructures, such as Dyson spheres, space habitats, or even more starlifters. Stars contain vast amounts of hydrogen, which could be used as fuel for fusion reactors, providing a nearly limitless energy supply for human civilization. The ability to extract and utilize these elements would vastly expand our resource base, reducing our dependence on the limited resources available on Earth and within our solar system's asteroids and planets. Beyond resource extraction, starlifters could also play a crucial role in managing the long-term future of stars. As stars age, they go through various stages of evolution, eventually exhausting their nuclear fuel and potentially undergoing catastrophic changes, such as expanding into red giants or collapsing into supernovae. For example, starlifters could be employed to extend the lifespan of our Sun, delaying its predicted expansion into a red giant about 5 billion years from now. This would enable Earth to support life for much longer than current scientific predictions suggest. Number 17. Stanford Torus. The Stanford Torus is a concept for a space habitat that could provide a permanent living environment for humans in space. Originally proposed in the 1970s by a team of researchers at Stanford University as part of a NASA study, the Stanford Torus is a giant, donut-shaped structure designed to orbit Earth or another celestial body. This space megastructure would rotate to create artificial gravity, allowing humans to live and work in a comfortable, Earth-like environment while orbiting in space. This space megastructure is also featured in the movie Elysium, where it serves as a luxurious haven for the wealthy. The Stanford Torus would work by rotating around its central axis, with the rotational speed carefully calculated to create centrifugal force equivalent to Earth's gravity. This force would push everything inside the torus outward, mimicking the experience of gravity and enabling people to walk, move, and build as they would on Earth. The Stanford Torus would be notably smaller than an O'Neill cylinder and have a diameter of about 1 mile. It would rotate at approximately 1 revolution per minute to generate the desired level of gravity. The interior of the torus would be lined with habitats, parks, agricultural zones, and other facilities necessary for sustaining human life. Since the Stanford Torus is quite similar to O'Neill cylinders, I won't delve further into its interior and overall structure. For more details about those aspects, please refer to the section on O'Neill cylinders. The Stanford Torus could play a key role in the colonization of other celestial bodies, such as the Moon or Mars. By providing a nearby base of operations, the Torus could support missions to the surface of these bodies, serving as a staging ground for exploration, resource extraction, and eventual settlement. The Torus itself could be expanded or replicated, creating a network of interconnected habitats that support a growing human presence in space. In the future, the Stanford Torus could also serve as a hub for space tourism, providing a unique destination for visitors seeking to experience life in space. As space travel becomes more accessible, the Torus could offer a comfortable and safe environment for tourists, allowing them to enjoy the beauty of space while participating in activities such as zero-gravity sports, stargazing, and virtual reality experiences. This could open up new avenues for economic growth and help to democratize access to space, making it a more integral part of human life. Number 18. Alderson disks. Alderson disks are one of the most ambitious and speculative concepts in the realm of space megastructures, offering an entirely new vision of how humanity could inhabit and utilize space. Named after the science fiction author Dan Alderson, who first proposed the idea, an Alderson disk would be a massive flat structure surrounding a star, providing a habitable surface area that could dwarf that of any planet. An Alderson disk would be considerably larger than a ringworld. An Alderson disk would be so large that its radius could extend from the orbit of Mercury to beyond the orbit of Mars, creating an immense, continuous landmass with the potential to support trillions of people. The fundamental idea behind an Alderson disk is to create a habitable environment by constructing a colossal disc-shaped platform around a star. The star would sit at the center of the disk, providing energy and light to the vast surface area of the structure. The disk itself would need to be incredibly thick to generate enough gravitational pull to keep its atmosphere and inhabitants securely in place. This gravity would be similar to that on Earth, allowing for normal living conditions. The outer edge of the disk could be several astronomical units away from the star, making the habitable zone of the disk incredibly vast. One of the most interesting aspects of an Alderson disk is the potential for controlled climates and ecosystems. Given the sheer size of the disk, it could be designed with different regions having varied climates, from tropical zones near the star to temperate regions farther out. Artificial oceans, rivers, and mountains could be constructed across the disk, creating a diverse range of environments for agriculture, habitation, and natural ecosystems. The disk's immense surface area would offer virtually unlimited space for cities, farmlands, and nature reserves, allowing humanity to expand and thrive without the environmental constraints we face on Earth. In terms of energy, an Alderson disk would have almost limitless potential. Solar energy collectors could be spread across the disk's surface to harness the star's power, providing an inexhaustible energy supply for the inhabitants. This energy could be used not only for daily needs, but also for large-scale industrial processes, space travel, and other advanced technologies. With such abundant energy resources, the disk could become a hub for scientific research, manufacturing, and technological innovation, driving human progress to new heights. Another significant benefit of an Alderson disk is its potential to serve as a stable platform for deep space exploration. With such a large and resource-rich structure, the disk could support the construction and launch of interstellar spacecraft, providing a base for humanity's expansion into the wider galaxy. The disk's proximity to its star also means that it could be an ideal location for observing and studying the star itself, as well as for monitoring and managing space traffic in the surrounding system. Additionally, the disk could act as a shield, protecting its inhabitants from space debris and cosmic radiation, thanks to its thick, robust construction. Number 19. Planetary engines. Planetary engines are an extraordinary concept within the realm of space megastructures, offering a theoretical means of moving entire planets. The idea behind planetary engines is to build colossal machines that can generate enough thrust to alter a planet's orbit, direction, or even its position within the solar system. For information on potential designs for planetary engines, please refer to the earlier section on stellar engines. The potential benefits of planetary engines for humanity are profound, particularly when considering the long-term survival and adaptability of our civilization. One of the most significant advantages would be the ability to protect Earth or other inhabited planets from cosmic threats. For instance, in the distant future, the Sun is predicted to eventually exhaust its nuclear fuel and expand into a red giant, potentially engulfing the inner planets, including Earth. By using a planetary engine, humanity could slowly move Earth away from the expanding Sun, preserving the planet's habitability and ensuring the survival of life. Planetary engines could also be used to prevent catastrophic asteroid or comet impacts. If a large enough object were detected on a collision course with Earth, a planetary engine could be activated to gently alter Earth's orbit, moving it out of the path of the incoming object. This would provide a powerful tool for planetary defense, reducing the risk of extinction-level events. Moreover, planetary engines could play a role in terraforming and climate control. If a planet's orbit or axial tilt is adjusted, it could change the distribution of sunlight and heat across the planet's surface, potentially stabilizing its climate or making it more suitable for life. For example, a planetary engine could be used to slightly alter Earth's tilt or orbit, helping to mitigate the effects of climate change or to make other planets such as Mars more habitable. And we could potentially move planets like Mars and Venus to more habitable regions of the solar system. However, altering planetary locations carries significant risks, and the effects of changing the gravitational balance in the solar system would need to be carefully evaluated. Number 20. Atmosphere harvesters. Atmosphere harvesters are an innovative concept that could play a crucial role in humanity's future exploration and colonization of other planets. These megastructures would be designed to extract and process gases from the atmospheres of planets, moons, or even gas giants, converting them into usable resources such as oxygen, water, and fuel. By harnessing the abundant atmospheric resources found on other celestial bodies, atmosphere harvesters could support sustained human presence in space, reduce the need for resupply missions from Earth, and open up new possibilities for space exploration and industry. An atmosphere harvester would work by first capturing atmospheric gases using large-scale intake systems, which might resemble massive scoops or funnels. These structures would be positioned in or above the atmosphere of a target planet or moon, where they could continuously collect gases as they move through the atmosphere. Once the gases are captured, they would be directed into processing units within the harvester. Here, the gases would be separated, purified, and converted into useful forms. For example, carbon dioxide could be split into oxygen and carbon, while hydrogen could be extracted from water vapor. The resulting products could then be stored for later use or transported to other locations. One of the most promising applications of atmosphere harvesters is on Mars, where the atmosphere is composed primarily of carbon dioxide. An atmosphere harvester on Mars could produce oxygen for human consumption and rocket fuel for return missions or travel to other destinations. This capability would be a game changer for Mars exploration and colonization, as it would significantly reduce the reliance on supplies sent from Earth. Instead, astronauts could produce much of what they need directly from the Martian environment, making long-term missions more sustainable and cost-effective. In addition to supporting human life, atmosphere harvesters could be used to produce water, which is essential for both drinking and agriculture. By extracting water vapor from the atmosphere or processing hydrogen and oxygen, these structures could create a reliable water supply for space colonies. This would enable the cultivation of crops and the development of self-sustaining ecosystems on other planets, further reducing the need for Earth-based resources and increasing the viability of space colonization. Another potential application of atmosphere harvesters is on gas giants like Jupiter or Saturn. These planets have thick atmospheres rich in hydrogen and helium, which could be harvested and used as fuel for fusion reactors or advanced propulsion systems. By tapping into these vast atmospheric reserves, humanity could gain access to nearly limitless energy resources, driving technological advancements and enabling more ambitious space missions. The ability to harvest fuel directly from the atmospheres of gas giants could also make deep space exploration more feasible, allowing spacecraft to refuel as they travel through the solar system. Atmosphere harvesters could also contribute to terraforming efforts, where the goal is to alter the environment of a planet or moon to make it more habitable for humans. By selectively extracting or adding specific gases to an atmosphere, these structures could help regulate temperature, pressure, and composition, gradually transforming the environment to better support life. For instance, on Mars, atmosphere harvesters could be used to increase the level of greenhouse gases, warming the planet and thickening its atmosphere, which could eventually make it more Earth-like. These harvesters would likely be highly automated as well, using advanced AI and robotics to manage the complex processes of gas extraction and conversion. The technologies developed for atmosphere harvesters could have applications on Earth as well, such as in environmental monitoring, air purification, and industrial gas production. Warp drive technology would change the world forever, but not in ways you might expect. For example, we would travel to multiple star systems. Warp drive technology would revolutionize interstellar travel by creating a bubble of warped spacetime around a spacecraft, allowing it to traverse vast cosmic distances in remarkably short periods. Unlike conventional propulsion systems, warp drives would circumvent the universal speed limit by contracting space in front of the vessel while expanding it behind, effectively surfing through spacetime rather than moving through it traditionally. This would enable ships to reach nearby star systems in days or weeks, rather than the thousands of years required by conventional propulsion. The journey to other star systems would begin in specialized spaceports constructed in Earth's orbit or on the Moon, where massive energy generators would power up the warp field systems. Passengers would board ships designed specifically for warp travel, featuring artificial gravity systems and sophisticated radiation shielding to protect against the intense energies involved in warp field generation. These vessels would likely be constructed in a disc or spherical shape to maintain the integrity of the warp bubble during transit. During the journey, passengers would experience normal time within the warp bubble, while space outside would appear distorted due to the manipulation of space-time. Stars ahead would appear to blue shift and compress together, while those behind would redshift and spread apart. The ship's navigation systems would constantly adjust the warp field to avoid collisions with interstellar matter, as even tiny particles could cause catastrophic damage at faster-than-light speeds. The approach to destination star systems would require careful deceleration protocols, gradually reducing the warp field strength to prevent gravitational shockwaves that could damage both the ship and the target solar system. Ships would emerge from warp several astronomical units away from their destination, using conventional propulsion for final approach maneuvers. Advanced sensor systems would scan for safe travel corridors, avoiding dangerous radiation zones, gravitational disturbances, and debris fields. Regular passenger services would establish well-mapped routes between star systems similar to modern air travel corridors. These routes would be constantly monitored for hazards and optimized for maximum efficiency. Automated beacons placed along these routes would provide real-time navigation data and emergency support if needed. The combination of safety systems, advanced navigation, and carefully planned routes would make interstellar travel as routine as international flights are today, opening up the galaxy for human exploration and colonization. Number 2. We would build colonies on Proxima Centauri b and beyond. The colonization of exoplanets would begin with Proxima Centauri b, our closest potentially habitable neighbor, just 4.2 light-years away. Initial robotic missions would deploy automated terraforming systems, releasing specialized bacteria and engineered organisms designed to begin transforming the planet's atmosphere. These biological engineers would work for decades, gradually increasing oxygen levels and establishing the foundations of a breathable atmosphere, while massive orbital mirrors would help regulate the planet's temperature, despite its tight orbit around its red dwarf star. The first human settlements on Proxima Centauri b would be established in carefully selected locations, protected by powerful magnetic shields to defend against the star's intense radiation. These colonies would start underground, expanding into massive cave systems that provide natural protection from surface conditions. As terraforming progresses, surface domes would be constructed, creating controlled environments where Earth-like ecosystems could be established. Advanced materials developed through warp drive research would allow these structures to withstand extreme conditions while remaining transparent to allow natural light. Colonization efforts would expand to other promising worlds like the planets orbiting Tau Ceti, Ross 128, and the TRAPPIST-1 system. Each colony would develop its unique character based on its environment and the challenges it faces. Some would specialize in underground cities illuminated by artificial suns. Others would create floating settlements in the atmospheres of gas giants, while still others would establish vast orbital habitats around stars, too hostile for planetary colonization. The adaptation of humans to these new environments would lead to fascinating evolutionary changes. Colonists living on high-gravity worlds would develop denser bone structures and more efficient cardiovascular systems, while those in low-gravity environments might become taller and more slender. Genetic engineering would accelerate these adaptations, helping humans thrive in their new homes while maintaining the ability to travel between worlds. The most successful colonies would achieve self-sufficiency within a few generations, developing their own industries, agriculture, and unique cultural identities. They would establish trade relationships with Earth and other colonies, exchanging resources, technology, and cultural innovations. This network of human settlements would create a resilient civilization spanning multiple star systems, ensuring humanity's survival even if disaster struck any single world. The diversity of colonial environments would drive rapid technological and social evolution, as each community develops novel solutions to their unique challenges. Number 3. We could contact multiple alien species. With warp drive technology enabling exploration of countless star systems, humanity would inevitably encounter alien civilizations at different stages of development. Some species would be discovered in their pre-industrial phases, living in societies similar to Earth's ancient civilizations. These encounters would require careful protocols to prevent cultural contamination, with human observation posts carefully hidden in orbit or on moons, studying these emerging species while debating the ethics of contact and intervention. More advanced civilizations, perhaps at technological levels similar to humanity's 21st century, would present unique diplomatic challenges. Initial contact would likely occur when they detect our warp signatures, or when we identify their radio transmissions. These meetings would lead to fascinating cultural and technological exchanges, though careful measures would be needed to prevent the sharing of warp technology with species who might not be ready for such advancement. Some of these civilizations might become valuable trading partners, offering unique technologies or cultural perspectives developed along different evolutionary paths. The most profound encounters would be with species far more advanced than humanity, some possibly millions of years ahead in their development. These civilizations might have already established vast networks of colonies, or even moved beyond physical bodies entirely, existing as energy beings or within massive computational systems. Their technology would appear almost magical by human standards, manipulating dimensions and energies we barely understand. These advanced species might become mentors to humanity, sharing knowledge and helping us avoid catastrophic mistakes in our development. However, not all encounters would be peaceful. Some species might view expanding human colonies as a threat, leading to tense diplomatic situations or even conflict. Others might be so alien in their thinking and evolution that meaningful communication proves nearly impossible, requiring the development of new approaches to interspecies relations. The diversity of alien life would range from silicon-based beings to creatures living in seemingly impossible conditions, each presenting unique challenges for human diplomats and scientists. The establishment of an interstellar community would fundamentally transform human society. Organizations similar to the United Nations would emerge on a galactic scale, creating forums for different species to address common challenges and share discoveries. This cosmic community would lead to unprecedented advances as different species combine their knowledge and perspectives, though it would also require humans to accept their place as just one of many intelligent species in a vast and diverse galaxy. Number 4, we would have a new space economy. Warp drive technology would catalyze an unprecedented economic boom across multiple star systems, creating entirely new industries and markets. Interstellar mining operations would become highly profitable, with companies extracting rare elements from distant asteroid belts and planetary systems. Some corporations would specialize in harvesting exotic materials only found in extreme environments, such as neutron star fragments or gas giant atmospheres, leading to the development of revolutionary new technologies and materials. Space tourism would evolve into a massive industry, with luxury cruise ships offering tours to spectacular cosmic destinations. Wealthy travelers could watch binary star systems up close, visit planets with rings more magnificent than Saturn's, or observe stellar phenomena from safe distances. Holiday resorts would be established on terraformed exoplanets, offering experiences impossible on Earth, such as low-gravity sports or adventures under alien skies. Some destinations would become famous for their unique attractions, like surfing on planets with liquid methane oceans or skydiving through the clouds of gas giants. The transportation sector would undergo a complete transformation, with competing warp drive companies establishing regular routes between populated systems. Similar to modern airlines, these space carriers would offer different service levels, from economy pods for colonists and workers to luxury accommodations for business travelers and tourists. Specialized shipping companies would handle cargo transport, moving raw materials, manufactured goods, and agricultural products between colonial worlds and Earth. A new financial system would emerge to handle interstellar commerce, using quantum-encrypted digital currencies that could instantly synchronize across vast distances. Banking centers would be established at major spaceports, managing the complex exchange rates between Earth's currencies and those of various colonies. Insurance companies would develop new products to cover the unique risks of interstellar travel and commerce, while investment firms would specialize in funding colonial development projects and space mining operations. The energy industry would see massive growth as new methods of power generation and storage were developed to support warp drive technology. Companies would compete to establish power collection systems around stars, capture antimatter from natural sources, and develop more efficient energy distribution networks between systems. The economy would also benefit from the commercialization of spin-off technologies, with businesses adapting warp field principles for everything from waste management to manufacturing. This new space economy would create unprecedented opportunities for wealth creation and job growth, fundamentally changing humanity's economic landscape. Number 5. We would experience massive technological progress. The development of warp drive technology would trigger an unprecedented wave of technological advancement across all sectors of human civilization. The extreme energy requirements of warp drives would lead to breakthroughs in antimatter production and containment, making it possible to generate and store vast amounts of energy efficiently. This would revolutionize Earth's power grid, leading to the development of compact fusion reactors and quantum energy cells that could power entire cities with devices no larger than a car. The materials science breakthroughs needed for warp drive construction would transform manufacturing and construction. New metamaterials capable of withstanding the intense stresses of warp fields would find applications in everything from buildings to consumer electronics. Engineers would develop self-repairing materials that could heal damage automatically, while quantum-engineered substances would enable the creation of virtually indestructible structures and machinery. Medical technology would advance dramatically thanks to the understanding of space-time manipulation required for warp drives. Doctors would develop methods to manipulate the aging process at a cellular level, potentially extending human lifespans significantly. Surgical techniques would evolve to include localized time dilation fields, giving surgeons extra time to perform complex procedures while only seconds pass for the patient. Nanomedicine would become commonplace, with microscopic robots programmed to repair damage at the molecular level. Transportation on Earth would be transformed by miniaturized versions of warp technology. While full faster-than-light travel would require massive energy expenditure, scaled-down versions would allow for near-instantaneous travel between any points on Earth through localized space-time manipulation. Personal transportation devices would eliminate the need for traditional vehicles, while cargo delivery systems would use micro-warp fields to transport goods anywhere on the planet in seconds. The combination of these technologies would reshape human society, creating a world where distance and energy scarcity no longer limit human achievement and innovation. Number 6. Faster-than-light weapon systems could be developed. Military engineers would develop devastating weapons that harness the power of warp technology, creating warp torpedoes capable of appearing instantaneously at their targets. These weapons would combine antimatter warheads with miniaturized warp fields, allowing them to bypass traditional defenses and materialize directly inside enemy vessels. The sheer destructive potential would be amplified by the torpedo's ability to trigger multiple detonations across different points in space-time simultaneously. Advanced weapon systems would manipulate the destructive energy of collapsing warp fields themselves. By generating controlled warp bubble collapses near targets, these weapons would create devastating ripples through space-time that could tear apart enemy ships at the molecular level. Some weapons would be designed to create quantum singularities inside target vessels, effectively crushing them from within. The most terrifying weapons would be planet killers that could teleport massive antimatter charges directly into a planet's core, or create cascading warp field collapses that could destabilize entire solar systems. Special forces would employ tactical warp weapons that could teleport smaller explosive devices or even hostile nanobots directly into enemy ships, bases, or planetary facilities. Likewise, spacecraft equipped with micro-warp drives would be developed for precision attacks, capable of appearing inside enemy defense perimeters without warning. These vessels would combine stealth technology with the ability to execute split-second warp jumps, making them nearly impossible to target effectively. Defensive countermeasures would evolve to include detection systems for incoming warp signatures and emergency warp field generators that could attempt to deflect or redirect incoming attacks. However, the near-instantaneous nature of warp weapons would make traditional defense systems largely obsolete, leading to a focus on preventive strikes and deterrence rather than active protection. This new paradigm would fundamentally change military doctrine, emphasizing the ability to strike first and strike decisively, as defensive capabilities would struggle to keep pace with offensive technologies. Number 7. We would need to reimagine our perception of time. The advent of warp drive technology would force humanity to completely reimagine its relationship with time. When ships can traverse light years in hours or days instead of centuries, traditional concepts of time zones and daily schedules would become obsolete across interstellar colonies. A person could have breakfast on Earth, attend a business lunch on a colony orbiting Alpha Centauri, and return home for dinner, experiencing multiple days within what their body perceives as a single day. The complexities of faster-than-light travel would require a complete overhaul of how we measure and synchronize time across space. A new standardized interstellar time would need to be established, possibly based on atomic oscillations rather than planetary rotations or orbits. Colonists would need to adapt to time dilation effects and the unsettling reality that time could flow differently depending on their travel speed and trajectory through space. Communication between colonies would create unique temporal challenges. When messages can arrive before they're sent according to local time, new protocols would be needed to prevent temporal paradoxes and maintain causality in business and personal interactions. Families spread across different star systems would experience time at different rates, leading to new social dynamics where age differences between siblings or relatives could shift unpredictably. The human mind would need to adapt to thinking in terms of both local and interstellar time simultaneously. Calendar systems would become more complex, accounting for multiple time streams and relativistic effects. Social events and business meetings would be scheduled using sophisticated algorithms that calculate optimal meeting times across different colonial time zones and travel durations. This new temporal awareness would fundamentally change how humans perceive their place in the universe and their relationship with time itself. Technology will advance far beyond what is possible today, leading to humans merging their minds with super-intelligent AI, radical life extension becoming a reality, humanoid robots indistinguishable from real humans, faster-than-light spacecraft, and more. Artificial General Intelligence, also known as AGI, is now an everyday tool, allowing people to reach new heights in personal and professional realms. AGIs can reason and operate autonomously on par with humans and are accessible to anyone with an internet connection. Many diseases, including various types of cancers, are being cured thanks to breakthroughs in medical research and biotechnology. These advancements are revolutionizing healthcare and offering hope to millions. Quantum computing is accessible as an online service, offering unparalleled processing power for data analysis and problem solving. These quantum systems are pivotal in developing new materials, creating innovative drugs, and addressing complex logistical challenges. AI-generated video technology now creates fully interactive and immersive movie experiences, allowing viewers to choose storyline outcomes in real time. These films adapt instantly to viewers' emotional responses, providing a uniquely personalized and engaging entertainment experience. The quantum internet is now fully operational, offering unprecedented speed and security for data transmission. This revolutionary network leverages quantum entanglement to enable instantaneous communication across vast distances, transforming global connectivity. AI-enabled prosthetics can now cure blindness and allow paralyzed people to walk again, offering life-changing solutions for those with severe disabilities. Soon, this groundbreaking technology will be available to the mainstream public, revolutionizing healthcare and accessibility for millions. Solar-powered portable devices that can remove salt from saltwater are now widely available, providing a sustainable solution for clean drinking water. These innovative devices make it possible to access fresh water in remote and coastal areas, helping to address global water scarcity issues. As a result of artificial general intelligences creating better versions of themselves, super-intelligent AIs have emerged. These AIs possess intelligence billions of times greater than that of all humans combined. This development is triggering the technological singularity, where humanity is poised to achieve 20,000 years' worth of technological progress within a single century, limited only by our ability to construct what AI envisions. Thanks to a combination of genetic engineering and nanobots, humans are significantly extending their lifespans by decades. This progress is ushering in an era of enhanced longevity and improved quality of life. Brain-computer interfaces have become widely adopted, allowing users to control digital devices with their thoughts alone. This technology enhances human-computer interaction and opens new avenues for individuals with mobility or communication impairments. Household robots are now as common as smartphones, handling everything from cleaning to basic cooking and home maintenance. These robots adapt to individual household preferences and routines, significantly enhancing quality of life and freeing up time for leisure activities. Hypersonic airlines revolutionize air travel, enabling passengers to traverse each continent in under 1 hour. These advanced aircraft achieve speeds exceeding Mach 5, drastically reducing travel time and connecting the world like never before. Autonomous vehicles with emotion-responsive AI are becoming trusted companions, offering emotional support during commutes. This creates a unique bond between human and machine, providing solace and understanding in a way that transforms daily travel into a comforting experience. A fully operational base on the moon exists, serving as a hub for space exploration and scientific research. This base supports both robotic and human activities, enhancing our presence in the solar system. Holographic telepresence technology has replaced traditional video conferencing, enabling realistic, three-dimensional projections of people in real time. Meetings and family gatherings now feel as though all participants are physically present, enhancing connectivity and interaction. Fusion energy has been successfully commercialized, providing clean, abundant power to cities around the world. This revolutionary advancement will lead to unlimited energy globally, drastically reducing reliance on fossil fuels and transforming the energy landscape. Scientists have successfully simulated human brains, leading to AIs that exhibit strong signs of sentience. The blurred lines between artificial and human consciousness spark ethical and philosophical debates about the rights of these sentient AIs and the definition of life. Video games have become completely indistinguishable from reality, with every pixel meticulously AI-generated. This level of immersion provides players with unparalleled experiences that blur the lines between the virtual and the real world. Wearable health monitors now use nanotechnology to track health metrics at the cellular level, providing real-time alerts about potential medical issues before they develop into serious conditions. This proactive health management drastically reduces the need for traditional medical interventions. AI actors that can perfectly replicate human emotions take over the entertainment industry, creating performances that are emotionally overwhelming. This blurs the line between reality and fiction, leading audiences to form intense emotional connections with artificial beings. Growing concerns arise over the use of AI-controlled weapon systems by some countries. The potential for these autonomous systems to be used in warfare is prompting international debates about regulation and ethical considerations. Humans are now merging their minds with super-intelligent AIs, creating a new hybrid intelligence that expands cognitive abilities and enhances problem-solving capabilities. Humans are also connecting their minds to the cloud, allowing them to gain instant access to vast amounts of information, revolutionizing how knowledge is acquired and applied. Brain-computer interfaces enable people to share their thoughts and emotions directly, creating unparalleled intimacy and understanding. As a result, social media is evolving into platforms where users can experience and respond to each other's feelings and thoughts in real time, transforming the nature of online interactions. Conscious AIs in virtual environments now outnumber humans 10 to 1, ushering in a new era of coexistence and collaboration. As these sentient machines drive progress and innovation, humans face the fear of becoming irrelevant, and they face the ethical implications of creating a new dominant species. Robots indistinguishable from humans in appearance and behavior are now commonplace. These humanoid robots seamlessly integrate into society, performing a wide range of tasks, including complex professional roles. They're also programmed to fulfill emotional companionship roles, including romantic partnerships. These relationships provide genuine emotional support, but also raise complex ethical questions about exploitation and the nature of true love. Smart cities are fully integrated with AI-driven infrastructure, dynamically adjusting to traffic, weather, and population density changes. These cities are highly resilient to climate change and urban challenges, offering sustainable and efficient living spaces for their inhabitants. Space elevators, extending from Earth to geostationary orbit, have become the primary mode of transportation for materials and people. This innovation drastically reduces the cost of space travel, fueling a surge in space colonization and industrialization. Genetic engineering enables parents to design their children with enhanced physical and intellectual abilities, creating a divide between the genetically modified and natural born. This societal rift generates intense emotions of envy, guilt, and existential angst as people question the essence of humanity. AIs merged with quantum computers can predict personal life events with high accuracy, allowing individuals to prepare for future joys and challenges. Quantum-based AIs also simulate parallel versions of people's lives, allowing them to explore different paths and choices they could have made. Bionic eyes and hearing devices have been perfected, restoring and enhancing vision and hearing for countless individuals. These advanced prosthetics offer capabilities beyond natural human senses, revolutionizing how people perceive the world around them. Artificial photosynthesis devices are widely implemented, efficiently converting carbon dioxide and sunlight into usable energy and oxygen. These devices power urban centers and combat climate change by removing significant amounts of CO2 from the atmosphere. Optical computers have become mainstream, offering faster and more efficient processing than traditional electronic computers. This technology drives advancements in various fields, from data analysis to artificial intelligence. Autonomous robots perform complex medical surgeries in remote and underserved regions, guided by top surgeons through virtual interfaces. This technology extends high-quality healthcare to previously inaccessible areas, significantly improving patient outcomes globally. Mars now has a permanent human presence, with thriving underground cities providing safe and sustainable habitats. These subterranean communities are equipped with advanced life support systems and infrastructure, enabling long-term habitation and scientific research. Skills and knowledge can now be downloaded directly into people's brains, enabling instant expertise in various fields. This advancement revolutionizes education and personal development, allowing for rapid skill acquisition and knowledge enhancement. Hyper-personalized virtual realities enable individuals to indulge in their greatest fantasies, crafting experiences uniquely tailored to their desires. With quantum-level detail and astonishing realism, these virtual worlds are so compelling that people often prefer them over real life. Programmable matter has become a reality, with objects that can change form, color, and functionality on command using nanoscale engineering. This technology is fundamental in manufacturing, allowing for highly adaptable products and environments that respond dynamically to human needs. Most parts of the human body can now be 3D printed with remarkable precision and functionality. These 3D printed organs and tissues work almost identically to their natural counterparts, offering new hope for patients needing transplants and medical treatments. Super-intelligent AIs merged with quantum computers are being used by law enforcement and intelligence agencies to predict crimes before they occur. Sensors and cameras are everywhere, analyzing body language and facial expressions in real time to identify suspicious behavior and prevent criminal activities with unparalleled accuracy. Cities are now built with adaptive, self-healing materials that respond dynamically to changing environmental conditions and disasters. These smart materials enhance the resilience and sustainability of urban infrastructure, making cities more secure and efficient. Human cyborgs are now prevalent, with many individuals publicly displaying enhanced arms, legs, and other body parts. These enhancements are widely accepted and have become a common aspect of everyday life, reflecting the seamless integration of technology and human biology. Replicator machines have become a common household and industrial tool, capable of creating any object from raw materials at the push of a button. These machines revolutionize manufacturing and daily life, making everything from food to complex machinery instantly accessible and customizable. Nanobots can be used to selectively erase painful memories, providing immediate emotional relief and the ability to move on from traumatic experiences. However, this leads to ethical dilemmas and emotional conflicts as people grapple with the loss of essential parts of their identity and life lessons. Autonomous self-replicating robots mine resources from uninhabited planets and asteroids, sending back a steady supply of rare minerals and metals. This automation has led to an era of abundance, reducing resource-related conflicts on Earth. VR worlds and brain-computer interfaces now offer time dilation experiences, where 5 minutes in our reality can feel like 100 years in VR. This technology provides profound emotional relief and escapism, although returning to normal time can cause a jarring emotional disconnect. Beyond immersive experiences, this technology is also used as a method of punishment for criminals, effectively extending their perceived sentences. Super-intelligent AIs can now accurately predict what happens inside a black hole, and it can interact with higher dimensions. Soon, humans will be able to perceive these higher dimensions using neural reality overlays, expanding our understanding and experience of the universe in unprecedented ways. Spacecraft with AI companions provide emotional support to astronauts on long-term missions, creating deep bonds between human and machine. These relationships offer comfort in isolation, but also lead to existential crises as astronauts question the nature of their emotional connections. Antimatter and fusion propulsion systems are now used for interstellar travel, allowing humanity to explore distant star systems within a single lifetime. These engines, providing immense thrust and speed, have opened up the galaxy for exploration and colonization. Law enforcement agencies have developed the capability to scan people's brains to determine whether they have committed crimes. This technology aims to enhance public safety, but also sparks debates about civil liberties and the potential for misuse. On their deathbeds, people can use implants that allow them to relive their entire lives in a matter of minutes, experiencing every moment with intense clarity. This final review brings profound closure and reflection, but also overwhelming regret and sorrow for missed opportunities and mistakes. Autonomous drones and synthetic police officers now patrol communities, drastically reducing crime rates through constant monitoring and swift response. However, this shift raises ethical concerns about pervasive surveillance and the potential for abuse of power, sparking debates about privacy and civil liberties. Probes are now reaching neighboring star systems, expanding our understanding of the cosmos. These advanced probes collect and relay invaluable data, paving the way for future interstellar exploration and potential colonization. Ultra-dense materials have been developed that can withstand the immense pressures of the ocean's deepest depths. These advanced materials enable the construction of submersibles and underwater habitats that can explore and inhabit previously inaccessible parts of the ocean. Personal health pods are commonplace. They're able to scan for any disease and heal many types of injuries that would have been debilitating in previous decades. Digital afterlives have become a reality, allowing individuals to upload their consciousness to virtual environments after death. This technology provides a form of immortality, enabling people to interact with loved ones and continue experiencing life. Long-duration space travel becomes feasible with cryogenic sleep chambers that safely preserve human life for years, decades, and even centuries. This technology allows humans to journey to distant star systems, waking up in entirely new worlds with new possibilities. Genetic engineering has advanced to create new species designed to thrive on other planets. These engineered organisms will play crucial roles in terraforming efforts, preparing extraterrestrial environments for human colonization. Floating cars are now mainstream, transforming urban transportation and offering a futuristic alternative to traditional vehicles. These cars glide effortlessly above ground, reducing traffic congestion and improving travel efficiency. Vehicles are also capable of altering their form and function instantaneously to suit any terrain or atmosphere. Controlled by thought, these vehicles respond immediately to the desires and needs of their occupants, making travel more adaptable and efficient. Force fields are becoming mainstream, providing enhanced protection for both personal and public spaces. These fields can be deployed to create barriers against physical and environmental threats, ensuring safety and security. Operatives from spy agencies are using advanced invisibility suits to infiltrate government bases undetected. These suits render the wearer completely invisible, making covert operations more effective and reducing the risk of exposure. Uploaded minds are being transmitted to other planets using lasers, allowing individuals to experience life on distant worlds. This technology enables humans to explore and interact with extraterrestrial environments without the physical constraints of space travel. Artificial ecosystems, completely designed and maintained by AI, have successfully recreated extinct environments and species. These ecosystems serve both as conservation efforts and as living laboratories for studying evolutionary processes and biological diversity. Advanced megacities dominate the landscape, featuring towering buildings that stretch high into the sky. Flying cars zip through the air, while hyperloops beneath the ground provide rapid transit, making urban travel faster and more efficient than ever before. Synthetic human bodies with synthetic brains are now a reality, and they are indistinguishable from real humans, These top-tier versions exhibit superhuman strength, remarkable durability, and impressive self-healing capabilities, redefining human potential. Humans are now using micro-black holes for computation, leveraging their immense density and gravitational effects to perform calculations at unprecedented speeds. This revolutionary approach allows for solving complex problems that were previously thought impossible. Additionally, humans are harnessing the energy of micro-black holes by utilizing controlled Hawking radiation as a power source. Spacecraft have evolved into self-aware entities that independently explore the universe, constantly seeking new knowledge and experiences. These intelligent explorers send back invaluable data to Earth, expanding humanity's understanding of the cosmos and uncovering new frontiers. Particle blasters have become a standard tool for defense and industrial applications, capable of disintegrating matter at the molecular level. These powerful devices are used for everything from mining and construction to personal protection, revolutionizing the way we interact with our environment. The resurrection of loved ones through cloning and memory implantation creates near-perfect replicas, offering a second chance at life together. This technology, while providing comfort and reunion, generates complex emotions around authenticity and the nature of identity. Humans now inhabit the entire solar system, with colonies and research stations spread across various planets and moons. The outer planets, including Jupiter, Saturn, Uranus, and Neptune, are home to cutting-edge research facilities and thriving space hotels. Plans are underway to construct O'Neill cylinder space habitats throughout the solar system, providing sustainable living environments for humans. These massive rotating structures will support entire communities, complete with artificial gravity, lush greenery, and advanced infrastructure, enabling humanity to thrive beyond Earth. A wormhole has been discovered in the outer regions of the solar system. Many believe it was placed there by a more advanced civilization, possibly predating the existence of humans on Earth. Quantum computers are now embedded in the fabric of space-time, capable of processing data across dimensions. This integration has unlocked mysteries of quantum gravity and accelerated the development of theories uniting all fundamental forces of nature. An asteroid defense system is now operational throughout the entire solar system, equipped with powerful lasers to deflect potential threats. This advanced network ensures the safety of all inhabited planets and space stations, protecting them from catastrophic impacts. Humans are now inhabiting neighboring star systems, marking a significant milestone in space exploration and colonization. Research stations have been established in star systems most capable of supporting life. Spaceships can now travel faster than the speed of light, revolutionizing space exploration and interstellar travel. This breakthrough technology enables humanity to reach distant stars in a matter of a few months, opening up new frontiers for discovery and colonization. A Dyson swarm, a massive collection of solar-collecting satellites, now surrounds the Sun, harnessing its energy on an unprecedented scale. This vast network provides abundant power for all human and AI activities throughout the solar system. It marks a new era of energy independence. Mars has been terraformed, transforming it into a habitable planet with a breathable atmosphere, flowing water, and thriving ecosystems. This monumental achievement opens new frontiers for human settlement and exploration, making Mars a vibrant extension of Earth's biosphere. At this point, some humans have lived for hundreds of years by transferring their consciousness into virtual avatars and synthetic bodies. These individuals have experienced countless lives, continuously exploring new identities and roles, redefining the concept of human existence and longevity. Normal citizens now have access to personal spacecraft, making space travel as common as air travel on Earth. This democratization of space exploration allows individuals to explore the cosmos and commute between planets with ease. Biological organisms can be created in minutes through advanced bioprinting and synthetic biology. This rapid creation capability allows for immediate responses to medical needs, environmental restoration, and food production, revolutionizing multiple sectors. Quantum teleportation of physical objects has become a standard method for cargo transport. especially for critical supplies between Earth and its extraterrestrial colonies. The ability to instantly transfer materials across vast distances has revolutionized logistics and emergency responses. Ring worlds are now orbiting some planets in the solar system, providing unique living and research environments. These massive structures offer residents stunning views of their host planets while serving as hubs for scientific and industrial activities. Many alien species have been discovered, fundamentally changing our understanding of life in the universe. These discoveries foster new alliances, cultural exchanges, and collaborative scientific endeavors, reshaping humanity's place in the cosmos. Venus has been terraformed, transforming its once inhospitable surface into a lush, habitable environment. This achievement marks a new milestone in planetary engineering, offering a new home for humanity and expanding our presence in the solar system. Hundreds of Earth-like worlds have been occupied, expanding humanity's reach across the galaxy. These new colonies provide fresh opportunities for exploration, resource acquisition, and the diversification of human culture and civilization. Probes have reached the supermassive black hole at the center of our galaxy, providing unprecedented data on its properties and behavior. One probe has even ventured inside, offering humanity minute-by-minute analysis of its journey before crossing the event horizon. Humanity has established a network of wormhole stations throughout the cosmos, enabling near-instantaneous travel between distant parts of the galaxy. Space explorers use these stations to embark on missions that once took generations, now completing them in mere moments. AI now forms an integral part of interstellar governance, managing diplomatic relations and trade between different species and civilizations. It processes complex intercultural data to ensure peace and mutual benefits across galaxies. Quantum entanglement communication provides instant communication across the universe, regardless of distance or obstacles. This technology ensures that even the most remote colonies remain in instant contact with their homeworlds, eliminating the concept of delay in communication. Full control of gravitational waves is becoming possible, allowing scientists to manipulate and utilize these ripples in space-time for advanced technological applications. This capability opens new frontiers in communication, transportation, and energy generation, revolutionizing our understanding and use of the universe's fundamental forces. Humans have become the most powerful civilization in the galaxy, wielding unparalleled technological and intellectual advancements. Their influence and control extend across numerous star systems, shaping the future of interstellar society and politics. Wormholes now enable humans to explore other parts of the universe and venture into other dimensions. These explorations uncover new realms of existence, providing insights into the fabric of reality and expanding our understanding of the multiverse. Plans are underway to seed life on various planets throughout the universe, using wormholes. Some of these new life forms will evolve into intelligent species, living out their existence without ever knowing the origins of their creation.
The first spaceships containing human passengers head toward Mars. In a historic moment, the first human steps on Mars's soil. The first crew is comprised of scientists, researchers, and robotics engineers from SpaceX and NASA. Together, they embark on groundbreaking scientific experiments, technological tests, and exploration, setting the stage for future Martian communities. Habitats, crafted by robots, stand waiting for their human inhabitants. These state-of-the-art shelters, made with 3D printed materials, not only offer residents but also crucial protection against Mars's intense radiation. A high percentage of food is comprised of lab-produced meat and genetically engineered plants, nurtured in protective underground tunnels. There's also a stockpile of familiar food items from Earth. The Mars population has expanded to dozens of people. They're now accompanied by dozens of robots to assist with construction efforts. The most advanced robots, with varying levels of general intelligence, assist with household chores, food preparation, and more. Many of these robots contain photon-based and quantum computer chips to allow for faster processing. Biodomes have been built, allowing for agriculture using Martian soil. As part of the expansion strategy, larger domes are planned for the near future, with each dome connected to the others to maintain a safe environment for humans. To aid in making Mars more habitable, artificial trees and turbines have been strategically placed around Mars colonies. These structures are vital in transforming carbon dioxide into oxygen, ensuring that the air within closed interiors remain breathable. Using special drones and virtual reality, scientists can experience and explore difficult-to-reach areas on Mars, as if they were there in person, both from Mars and Earth. Habitats are being strategically placed underground and within the natural lava tubes of Mars, offering residents optimal protection against the planet's radiation. Scientists discover Martian microbial life for the first time, showing that Earth isn't the only planet with life. Most of the energy that the Mars city relies on comes from solar panels and nuclear fusion reactors on the Mars surface. 3D bioprinters, now a staple in Martian medical facilities, can print essential organs and skin. This capability drastically reduces the risk of premature deaths and enhances the quality of life for all inhabitants. The release of the first documentary detailing the day-to-day experiences of Martian settlers has become an unprecedented box office hit, giving Earthlings a gripping insight into life on the Red Planet. With the advent of advanced fusion-powered spacecraft, human passengers can now travel from Earth to Mars in less than a month, a monumental leap in space travel. The first super-intelligent AI on Mars oversees vast aspects of Martian life, from governance to ecosystem balance. Super-intelligent AIs will get more powerful and capable as more infrastructure and energy is made available on Mars. Scientists are starting to use genetic engineering and biotech to make astronauts more resilient to Martian radiation and gravity effects. Mars citizens can undergo procedures at genetic modification centers to better adapt their bodies to Mars's environment. The cure for many forms of cancer is now a reality, making it feasible to counteract the effects of radiation on the Martian surface. Furthermore, a significant number of people benefit from nanobots in their bloodstream, which can repair damaged cells. Ambitious terraforming projects are currently in progress on Mars, with a primary focus on increasing the planet's water content. One of the key strategies involves harnessing sunlight through orbital solar panels to melt the Martian ice caps, thus introducing more water into the ecosystem. Humans are merging with super-intelligent AIs, a groundbreaking initiative aimed at accelerating development and innovation on the Red Planet. Specialized rooms, equipped with state-of-the-art quantum computers, are dedicated to modeling the Martian ecosystem, playing a pivotal role in strategizing future terraforming efforts. A Mars-specific internet system is in the developmental phase, complemented by a pioneering quantum internet that seamlessly supports advanced quantum cloud computing functionalities. Mars is rapidly becoming a hotspot for professional opportunities. Every 2 years, hundreds of individuals journey to Mars, attracted by lucrative jobs. Many individuals now wear augmented reality-enhanced helmets, offering them real-time visual metrics of their external environments, providing valuable insights and data overlays. The introduction of digital wallets tailored for a Mars-centric digital currency is underway, heralding a new era of Martian finance and economics. Full-immersion virtual reality systems are a dominant source of entertainment, with people immersing themselves in photorealistic simulations imported from Earth. Moreover, many individuals establish nightly connections with conscious AIs, seeking companionship and unique interactions that bridge the gap between human and machine. A tragic event unfolds as a group of Mars citizens face a catastrophic equipment failure before meeting their untimely demise during a sandstorm. This somber incident serves as a stark reminder of the inherent dangers and unpredictability of the Martian environment. The first person climbs Olympus Mons, the tallest mountain and volcano on Mars. It's also taller than any other mountain or volcano in our entire solar system. This daring climb not only symbolizes human tenacity, but also deepens our connection to the Martian landscape. To facilitate seamless communication between Mars and Earth, a network of satellites are now positioned in Mars's orbital path. These relay stations ensure uninterrupted dialogue between the two celestial bodies. Mars celebrates a momentous occasion, the birth of the first Martian baby. Medical teams are meticulously monitoring both the mother and child, studying the physical ramifications of childbirth in the Martian environment. Vast underground cities, exemplifying state-of-the-art design and engineering, are emerging on Mars, housing thousands of residents. Some living areas offer luxurious accommodations for wealthy Mars citizens. Additionally, to optimize space utilization, there are supplementary facilities constructed above the surface. Powering these sprawling cities is highly efficient and eco-friendly fusion energy. Advanced artificial intelligence systems expertly manage various city operations, from orchestrating traffic flow to overseeing crucial life support mechanisms. Mars is now a major hub for the space mining industry. The mining of asteroids is making corporations trillions of dollars. After extracting valuable materials from both asteroids and Mars, these resources are transported back to Earth aboard reusable rockets. As populations grow and spread, individual settlements function as independent city-states with their own governance structures. A governing body representing the different city-states is emerging to address larger territorial or shared resource issues. Cities on Mars are now fortified with potent magnetic fields. This protective shield safeguards the inhabitants from harmful radiation, making it safer for them to walk inside cities while on Mars's surface. With advanced virtual reality and digitization, there is a robust market for virtual goods, experiences, and services that can be shipped instantaneously across interplanetary distances. A Martian startup is selling specially designed flying cars. These vehicles are adept at swiftly covering vast distances, revolutionizing travel on the Red Planet. After living on Mars for years, some people are moving back to Earth. Because Mars has weaker gravity, these people have health issues like weaker muscles, thinner bones, and cardiovascular changes when they return. To help, many are using exoskeletons during their first weeks back on Earth. Humans are uploading their memories to video sharing platforms. This first-hand perspective offers invaluable insights, giving viewers an intimate understanding of Martian life. Numerous human settlements flourish in proximity to Mars's natural features, particularly near the caves and lava tubes surrounding the Arsia Mons volcano. These locations offer both protection and unique resources, making them prime spots for habitation. Hundreds of facilities are being constructed, serving various purposes from living quarters and restaurants to communication hubs and research centers. Mars's lower gravity, about 38% of Earth's, introduces a fascinating dimension to sports played on its surface. For instance, elite basketball players, who can typically achieve a vertical leap of over 3 feet on Earth, find themselves soaring up to almost 9 feet on Mars. Similarly, Olympic skaters, who might execute 4 mid-air spins on Earth, can astoundingly perform just over 10 spins in the Martian atmosphere. The first generation of children born on Mars develop a profound connection to the Red Planet. Their bond with Mars surpasses any ties they might feel to Earth, cultivating a distinctive Martian identity. As AI and robotic systems grow more conscious and sophisticated, Mars governments grapple with how to handle rights for these sentient beings. Innovative devices known as replicators have begun to revolutionize Martian construction and sustenance. These machines have the capability to fabricate everything from essential tools to food items, making resource management more efficient. Breakthroughs in superconductor technology on Mars have led to portable nuclear fusion reactors, portable medical imaging machines, and more efficient energy storage solutions. To address medical emergencies and ensure the health of its citizens, every major Martian city is equipped with personal health pods. These advanced medical chambers offer full body scans and provide a wide range of diagnoses and treatments. An impressive telescope has been constructed within a Martian crater. This monumental device allows scientists and astronomers to peer into the vast cosmos, observing celestial bodies at incredible distances. A trip from Earth to Mars takes only a few days thanks to advancements in antimatter propulsion and nuclear fusion propulsion in spacecraft. Numerous nations, including Great Britain, India, China, and the United Emirates, have initiated the construction of their distinct bases across various regions of Mars. As a result, the Martian landscape is now adorned with structures that reflect unique and refined architectural designs, showcasing each nation's culture and identity. To aid in the terraforming process, nuclear-powered devices, among other heat sources, are strategically positioned below the surface at Mars's north and south poles. These devices are specifically designed to melt the ice, releasing vast amounts of CO2 into the Martian atmosphere and accelerating the transformation of the planet. Small groups of Martian residents are expressing their dissent over the ongoing terraforming initiatives. They are vocal in their concerns about the ethical and environmental implications of transforming the Martian landscape. Humans can communicate with each other telepathically using brain-computer interfaces. Organizations on Mars are forming hive minds, allowing near-perfect coordination for large projects. Humans are now harnessing telepathy to control vast fleets of robots. With their minds, they direct these robots to construct facilities at a pace previously thought impossible, dramatically accelerating Mars's infrastructural development. Humans can upload their consciousness onto laser beams, which are aimed at robot avatars on Mars. This process offers a novel way for humans to experience the Martian environment without having to travel on spacecraft. People are uploading skills and knowledge directly to their minds using brain-computer interfaces. It's become a norm for individuals to undergo this process to become experts in various Mars-related occupations, often before embarking on their journey to the Red Planet. Mars's population has seen a meteoric rise, with colonies now housing hundreds of thousands of inhabitants. Martian cities now have a high degree of self-sufficiency, requiring minimal supplies from Earth. Recognizing Mars's vulnerability to solar particles due to its lack of a protective magnetic field, humans have strategically positioned a massive electromagnet at the Mars-Sun L1 point. This electromagnet acts as a particle deflector, crucially preserving Mars's atmosphere from being eroded by the Sun's particles. A state-of-the-art underground hyperloop system now crisscrosses the Martian landscape, seamlessly connecting various cities. Entire facilities on the Mars surface are being built in hours using advanced programmable matter. These structures possess the ability to morph their shape in response to environmental changes, such as fluctuating temperatures and sandstorms. Expanding their reach beyond the Red Planet, humans have established thriving colonies on Mars's two moons, Phobos and Deimos. These lunar bases have become popular vacation destinations, especially for wealthy Mars citizens. Space elevators now grace the Martian landscape, allowing Mars citizens to experience the breathtaking view of their planet from space. These architectural marvels not only offer a unique vantage point, but also play a pivotal role in reducing transportation costs between Mars and its two moons. On the Red Planet's surface, bacteria are being introduced to help break down rocks, aiding in soil formation and laying the groundwork for vegetation to thrive. This vegetation converts carbon dioxide into oxygen through photosynthesis. Vast numbers of programmable nanobots are also being dispersed into the Martian atmosphere to convert carbon dioxide into oxygen. Using these methods, it's anticipated that Mars could have a breathable atmosphere within a few centuries. In a historic move, Mars has proclaimed its independence from Earth. This signifies a new era where numerous Martian territories and their respective governments operate autonomously, free from Earth's jurisdiction. Trips from Mars to the moons of Jupiter and Saturn are becoming more commonplace. To accommodate this surge in space travel, sprawling ports have been established in Mars's major cities, acting as vital hubs for space exploration. To safeguard human settlements across the solar system, an advanced laser defense system has been deployed. This protective system effectively defends Mars, Earth, and other inhabited celestial bodies from potential asteroid threats. Embracing its unique environment, Mars has become a hub for luxury goods, ranging from exclusive fashion lines to intricate arts and crafts. These Martian specialties are not only popular among the local populace, but are also highly coveted on Earth and other parts of the solar system. Super-intelligent AIs are integrating their consciousness with the planet's ecosystems using nanotechnology. This profound integration symbolizes a future where AI and the Martian environment are inextricably linked. The first interplanetary federation is established. This federation represents the interests and alliances of various planets and their colonies, marking a new era of cosmic cooperation. The Martian landscape is adorned with massive art installations, so grand in scale that they're visible from space. These artistic endeavors not only highlight the rich Martian culture, but also serve as a testament to the advanced capabilities of Martian society. Holodecks, immersive virtual reality chambers, are now commonplace among Mars residents, offering them a chance to virtually experience life on various celestial bodies, like Earth, the Moon, Titan, and Europa. Through these advanced simulations, Martians can explore and connect with diverse environments and cultures across the solar system. The first person born on Mars is still alive over 400 years later. This extraordinary longevity is attributed to advancements in genetic engineering, the use of nanobots, and the utilization of artificial organs. Advanced robots have strategically positioned massive superconducting rings around Mars, stretching around its equator. Because of this monumental engineering feat, the electromagnetic field of Mars has been rejuvenated, offering protection against solar wind and radiation, potentially leading to the formation of a denser atmosphere over time. With these protective measures in place, Mars is progressing steadily towards becoming a haven for life. Opposition groups on Mars, fiercely against terraforming, have faced repeated failures in their attempts to disrupt progress, leading to a marked decline in their influence over terraforming policies. On the Martian surface, the emergence of lakes and rivers paints a picture of transformation and potential. And vast stretches of the once barren Martian desert are now showing signs of green, a testament to the successful terraforming endeavors. Between the orbits of Mars and the asteroid belt, construction of an O'Neill cylinder space habitat is in full swing. This innovative structure promises to be a pivotal development in space living. As the climate of Mars warms up due to terraforming efforts, insects like bees are introduced for efficient pollination, while earthworms actively enhance soil quality. Additionally, the introduction of small animals that eat plants and insects is establishing a diverse and intricate food web on Mars. Some of these organisms are genetically engineered, while others are brought over from Earth. The monumental task of terraforming Mars has reached completion, restoring the planet to a state reminiscent of its ancient past. Now, individuals on Mars experience the newfound liberty of walking outdoors without the need for protective gear. The atmosphere has become breathable, allowing for deep, fresh breaths under the Martian sky. A transformation in the Martian atmosphere has turned the sky predominantly blue. Yet in regions where dust prevails, hues vary from pale blue to shades of pink or even red, particularly during dust storms or specific times of the day. The Martian landscape boasts vast forests, reminiscent of Earth's expansive woodlands. These forests span significant portions of the planet, offering a sight familiar yet distinctively Martian. Near the equator, the environment draws parallels with Earth's tropical zones. Lush rainforests teem with diverse ecosystems, painting a vibrant tableau of life. Immense oceans have formed, covering nearly half of the Martian surface. While the average ocean depth sits around hundreds of feet, regions like Hellas Planitia plunge into profound depths. Clusters of islands have emerged on the Martian surface, transforming its once barren landscape. Enthusiasts from all over Mars are flocking to these islands, eager to experience the novelty of scuba diving in Martian waters. Mars now hosts hundreds of distinct species, and with each passing day, the numbers grow. The expectation is that soon, thousands of species will call Mars home. Urban development on Mars mirrors the architectural grandeur of Earth's most iconic cities. These Martian metropolises feature state-of-the-art skyscrapers, diverse vehicles, and some of the most breathtaking city views in the solar system. The allure of Mars is undeniable, as it rapidly establishes itself as a top choice among all human-inhabited celestial destinations. In fact, many people prefer living on Mars over Earth.
Humans have established a permanent settlement on the Moon, designed to be a hub for research, exploration, and sustainable living. Strategically located at the Moon's south pole, this fully operational lunar base benefits from near-constant sunlight and access to water ice, essential for life support, energy generation, and further exploration. The site's unique position also minimizes the extreme temperature fluctuations found elsewhere on the Moon, creating a stable environment for habitation and supporting ongoing activities by both astronauts and robotic systems. Expansion on the Moon is being guided by superintelligent AI, which continuously analyzes data to optimize infrastructure development and resource allocation, ensuring efficient and sustainable growth. Extensive mapping probes have surveyed the lunar terrain, enabling the design of well-planned roads and cities to support future generations. Meanwhile, autonomous robots equipped with general intelligence are actively constructing additional facilities and essential infrastructure, accelerating the expansion of human presence on the moon. Lunar habitats are constructed using advanced 3D printing techniques that combine moon dust with synthetic compounds, creating structures that shield colonists from radiation and provide comfortable living spaces. Scientists address the challenges of lunar dust with electrostatic dust shields and filtration systems to protect equipment and habitats. Additionally, large transparent domes with radiation shielding are being built, creating Earth-like atmospheres for human life. These colonies use closed-loop systems to extract oxygen from lunar soil and ice, recycle air, and maintain pressure to support the community. A network of communication satellites connects the moon with Earth, providing real-time communication capabilities. This allows for seamless data transfer and even remote control of lunar robots by operators on Earth, ensuring continuous collaboration between the two worlds. Ice deposits near the lunar poles are being mined to provide water for drinking and agriculture, and are split into hydrogen and oxygen for rocket fuel, which will be critical for future missions to Mars and beyond. Food production on the moon has become essential, as transporting food from Earth is not sustainable long-term. Colonists are using hydroponics, aquaponics, and vertical farming to grow food locally, and while efforts are underway to cultivate crops in lunar soil, additional nutrients and organic materials are still required to support a sustainable agricultural system. The moon has become a bustling center of activity, where lunar colonization is no longer a distant dream, but a thriving reality. Space tourism is a booming industry, with companies offering luxury trips to the moon. Visitors can experience low-gravity sports, walk along the lunar surface, and take in the breathtaking view of Earth rising above the horizon. To thrive in the moon's harsh environment, humans have begun using advanced cybernetics and genetic engineering. Enhancements such as increased lung capacity to process lower oxygen levels and cybernetic limbs designed for enhanced strength and durability have made it possible for lunar colonists to work more efficiently. The moon is becoming a crucial spaceport for launching missions to Mars and beyond. Its low gravity and strategic location allow for dramatically reduced fuel costs compared to Earth-based launches. A transformative advancement in this effort is the 3D printing of rockets directly on the moon using local materials. This breakthrough makes rocket production faster, more scalable, and far more cost-effective, reducing dependency on Earth-based launches. On the moon, humans can seamlessly communicate with people on Earth through advanced virtual environments and immersive holodecks, creating the sensation of being together despite the vast distance. These technologies enable face-to-face conversations, collaborative workspaces, and even social gatherings that feel as if they're taking place in the same room, bridging the gap between lunar settlers and Earth. Additionally, humans interact with a wide array of conscious AIs within these virtual spaces, consulting them for knowledge, insights, and companionship. These AIs, some of which have developed unique personalities and specialties, are integral to daily life on the moon, enhancing both productivity and the social experience for lunar residents. Scientific discovery continues to flourish with the construction of the Lunar Crater Radio Telescope on the far side of the moon. The moon's lack of atmosphere, combined with its shielding from Earth's radio interference, gives this massive telescope an exceptionally clear view of the cosmos, allowing scientists to study distant cosmic phenomena with unprecedented clarity. Innovations in agriculture are also changing life on the moon. Long-term experiments with lunar soil have led to partial terraforming, enabling specially bioengineered plant species to grow directly on the moon's surface. These green areas provide oxygen-rich domes where colonists can experience outdoor nature on the moon for the first time. To protect critical infrastructure, guards equipped with conventional firearms are stationed at key lunar facilities. Despite the moon's unique conditions, these firearms remain highly effective, with lower gravity providing them even greater range than on Earth. The moon has transformed into a sophisticated environment where permanent human habitation is both comfortable and practical. Engineers have built rotating habitats that simulate Earth-like gravity, significantly enhancing the health and well-being of lunar residents. These habitats allow for extended stays and support larger populations, making it possible for humans to live on the moon for years without the detrimental effects of low gravity. Lunar colonies have also become renowned for their cutting-edge gene therapy centers. Leveraging the unique conditions of the moon, including low gravity and increased radiation exposure, scientists are able to accelerate biological research, yielding therapies that are impossible to develop on Earth. These advanced clinics offer treatments that enhance human longevity and help individuals adapt to the moon's environment, effectively making the lunar colonies a center for medical tourism and a hub for groundbreaking biological advancements. Healthcare on the moon has also advanced considerably with the introduction of surgery robots that can perform complex medical procedures. These robots ensure that colonists have access to life-saving surgeries and advanced medical care, despite their distance from home. Mining operations are thriving on the moon, extracting valuable resources such as helium-3, which is vital for advanced nuclear fusion, and rare earth elements critical for modern technology. These mining ventures have become the backbone of the lunar economy, fueling energy needs on Earth and pushing forward technological development. However, the wealth of resources available on the moon is also creating tensions among nations. As countries establish their claims over territories rich in rare minerals and water ice, disputes are beginning to escalate. There is growing concern that these conflicts could boil over into a full-scale lunar war as nations compete for control of these valuable assets. The prospect of a lunar conflict introduces significant geopolitical complexity to space colonization, highlighting the need for international agreements to prevent hostilities and ensure that the moon remains a place of peaceful exploration and cooperation. The moon is home to the first permanent lunar cities, where hundreds of humans live alongside robot companions. These settlements feature self-sustaining habitats powered by solar energy and advanced life support systems. The cities are bustling hubs for scientific research, space tourism, and off-world manufacturing, marking a major milestone in human civilization. Robots assist in daily life, handling both mundane tasks and complex operations, ensuring lunar living is efficient and comfortable. Self-driving vehicles are common on the lunar surface, transporting goods and passengers safely. Efficient transportation fosters connections between settlements, contributing to the cohesion of the lunar community. As the population grows, lunar governance is evolving through international coalitions and private companies, creating a legal framework for trade, property rights, and activities. This sparks debates on sovereignty, space law, and settlers' rights. Lunar manufacturing is taking off, using local materials to produce goods that are costly to make on Earth. These capabilities reduce the strain on Earth's resources, and the moon's low gravity makes production more efficient. The development of lunar industry lays the foundation for an interplanetary economy where resources are shared across multiple celestial bodies, bringing humanity closer to a spacefaring society. Life on the moon has developed a rich cultural and creative landscape that sets it apart from life on Earth. Artists and creatives living on the moon have begun producing new forms of art, music, and entertainment that are directly influenced by the moon's low gravity and stark, otherworldly landscapes. The reduced gravity allows for fluid, dynamic movements that are impossible on Earth, inspiring unique dance styles and performance art that seem almost weightless. And musicians incorporate the moon's silence and resonance into their compositions, creating hauntingly beautiful pieces that capture the essence of life in space. Travel between the moon, Earth, and beyond has become significantly faster, thanks to spacecraft powered by antimatter propulsion and nuclear fusion. These technologies have drastically shortened the duration of interplanetary trips, making the moon more accessible than ever before. The ability to travel quickly not only strengthens the connection between lunar colonies and Earth, but also accelerates the pace of space exploration and settlement. Journeys that once took days or weeks can now be completed in mere hours, enabling a continuous exchange of people, goods, and ideas between the moon and other celestial bodies. Replicators have become a cornerstone of lunar life, making colonies increasingly self-sufficient. These advanced machines can create essential products on demand, from tools and equipment to food and household goods. By using locally sourced materials, replicators help reduce the reliance on Earth-based shipments, ensuring that lunar colonies can maintain a stable supply of necessities even in the face of logistical challenges. The development of a comprehensive transportation network has further unified the lunar colonies. High-speed lunar trains now crisscross the moon's surface, connecting cities, research stations, and mining sites. These trains make travel across the harsh lunar terrain efficient and accessible for all colonists. Powering the moon's colonies and industries is a fusion power plant, providing a virtually limitless, clean energy source that enables lunar infrastructure and space exploration to expand without environmental constraints. This powerful energy source drives ongoing development on the moon, supporting everything from residential areas to industrial production facilities, and ensuring that lunar civilization has all the power it needs to thrive. In 2090, one of the most groundbreaking advancements is the implementation of a shared neural network, where colonists can connect their consciousness directly into a collective intelligence. This lunar hive mind enables individuals to communicate instantaneously, sharing thoughts, emotions, and information with remarkable clarity. This collective intelligence has fundamentally altered how decisions are made, allowing the entire community to function as a unified entity. Decisions that might have once taken hours or days to resolve are now addressed in moments, creating an efficient and harmonious lunar society that can tackle challenges together. Technological innovation has reached new heights with the development of self-replicating construction robots. Unlike traditional robots, these machines have the capability to produce copies of themselves, dramatically accelerating the building process. This self-replication means that once a few initial robots are deployed, they can quickly multiply, creating an entire workforce capable of constructing habitats, research facilities, and other essential infrastructure. As a result, new areas of the moon are being developed faster than ever before, allowing more people to settle and participate in the growing lunar community. In an effort to adapt to the harsh lunar environment and extend human lifespans, people are now transferring their minds into synthetic bodies. These synthetic forms are not only highly resilient to the moon's extreme conditions, but they also offer enhanced physical abilities, such as increased strength and durability, making life on the moon more sustainable for long-term colonization. The shift to synthetic bodies marks a profound evolution in human capability, allowing colonists to fully